So let's practice the override function one more time, and this time we're going to practice overriding our random fact because the isAlpha doesn't really make sense for our lion cubs here. But before we do that, we're going to want to create another property that's only available for our lion cub. We've started off with functions here, but this property, the lion class, will know nothing about this property. And we're going to simply put gender here. So we're going to say var is male, and we're going to set this equal to false. So we're going to set its initial state to be a female. And let's go ahead and we're going to override the function random fact. And we know that this is going to return a string. So we can put string here. And let's go ahead and add our curly braces here. So we know that we need to return a string. We can just return two quotes for now, which is an empty string. We'll update that in just a minute. So let's add an if statement here. We're going to say if is male, right? If it is a male, we're going to add a random fact for our lion cub. And let's go above our if statement here and let's create a variable so we can, set our string equal to this. So we'll say our random fact string, and we'll say this is going to be a string. And let's say random fact string is going to be equal to cubs are usually hidden in dense bush for approximately 6 weeks. And we'll say else, and we can say that cubs begin eating meat. So we'll say random fact string is equal to cubs begin eating meat at about the age of 6 weeks. So we have two here. These aren't really dependent on it being male or female, but it will be different based on whether or not we're going to have a male or female cub, which is great. We'll have some consistency on our view. And we also want to return our random fact string. So let's go back to our view controller.swift file. And we want to first create another lion cub instance here, right? We have a male lion cub instance, but it'd be nice to have a female lion cub instance as well. So let's say var female lion cub is equal to lion cub, and we'll create our instance here. And let's set up the properties for our lion cub here. So we're going to say female lion cub dot age is going to be equal to 1. So lion cub, so we'll make it young. We'll say female lion cub dot name is going to be Nala, and we can say female lion cub dot image is going to be equal to UI image named, and we can say lion cub 2 dot JPEG. Very important that we put this in as JPEG. Again, we're using JPGs and JPEGs. If you don't put the right file extension, our image isn't going to be able to be loaded properly. And we're going to say female lion cub dot subspecies is going to be Transvaal. And let's not forget to set up the gender here. So we're going to say female lion cub dot is male. We're not going to do is alpha male is equal to false. Let's also make sure we set up for our lion cub the gender as well. So we're going to say lion cub dot gender or dot is male, and we're going to say this is equal to true. So now we have two different lion cubs here, and in our next video we're going to want to figure out how we can add these to an array, and then how we're going to display these. Since we only have lion and tiger set up, we're going to figure out how we can add a lion cub into our update animal in our update view as well. So the first thing we're going to do in this video is we're going to set up a property that's going to be an array to hold our lion cubs. So let's go to the top of our view controller file, and we've done this before for lions and tigers. So we're going to say var lion cubs colon, and we're going to put lion cubs. So we're just going to do a lion cub inside of this array, and let's just initialize this empty array. We can then add both of our lion cubs, and let's do this the way we did this for our lions. We can just say self.lion cubs. Notice we're using the self keyword because this is a property. And we can do plus equals, and we're going to enter our lion cub and our female lion cub. So we have both of these in here now. We next want to update our update animal function here. And right now, the way our update animal function is, if we have a tiger, we want to show a lion. Otherwise, we want to show a tiger. Well, what we want to add here is, if we have a lion, we want to show a lion cub. So we're just going to add another case, and we're going to say case lion, and we don't care about our second parameter, which is going to be the index. We don't need those curly braces either. We need a colon, excuse me. And we're going to put in current animal is equal to, and we're going to make our tuple here. We're going to say lion cub, comma, and we need a random index. Well, we can do that. We can just copy and paste this code above. And instead of doing lions.count, we should do lion cubs.count, right? We want to use our lion cubs count in case we add additional lion cubs in the future. And we can just add our random index here. All right, so basically what's happening now in this update animal function, we're starting off with the tiger. If it's a tiger, we're going to go to lion. If we have a lion as our current animal, we're going to go to lion cub. And if we have a lion cub as our current animal, we're going to switch that over to a tiger. So we're going to be able to rotate through all three of our types here. The next thing we want to do is we're going to want to update our update view function, and we set this up ahead of time with just an else if, so it'd be really easy to extend this to include the lion cub. So we're just going to right below here, else if, we can say self.currentAnimal. Again, current animal is a property, so we can use the self keyword, and we're inside of a closure, so the property or the self keyword is actually required here to access our property. So we're going to say if self.currentAnimal.species is equal to lion cub, and we're just going to add a set of curly braces here. We'll say let lion cub equal self.lion cubs, and we'll say self.currentAnimal.index. Right, so we're just going to index into our lion cubs array using the current animal index, right, from our tuple. And once we get this lion cub back from our lion cubs array, we're going to be able to update our view. So we're going to say self.myImageView.image is equal to lion cub.image, and we can update our breed label. And we're going to update the text property of our breed label, and we're going to set that equal to lion cub.subspecies. And let's update our age label. And we can say that this is going to be equal to our lion cub's age here. So we're going to say lion cub.age. And we also want to update the name label. So we can say self.namelabel.text is equal to, and we'll set this equal to our lion cub.name. And finally, we want to get our random fact. So we're going to say self.randomFactLabel.text. We're going to set this equal to our lion cub.randomFact. And remember that we adjusted our random fact, right? We overrode the random fact function, and we added our own additional functionality here. So now we should be able to see both our tigers, our lions, and our lion cubs inside of our application. So let's go ahead and run our application here. And as soon as this thing loads up, we should be able to iterate through our different arrays here. And notice that we had to write this bit of code here while we're waiting for this thing to load up, because in our array of tigers, we had to only have tigers. In our array of lions, we could only have lions. And in our array of lion cubs, we could only have lion cubs. So let's go. We have tiger. Let's go over to lion. Hopefully we see our lion cub next. Oh, and there is Simba. Awesome. Let's see. We see a tiger again, a lion, and we should see a lion cub again. and now Nala has popped up. So we're now able to see our lion cubs inside of our application. Welcome to our new application. We're going to be building a slot app. Specifically, it's going to be called Slot Machine. And there's one really big change inside this application. We take a look at our storyboard here. We see that it's completely empty. And that's because we're going to be building all of our view code programmatically. So normally we set up our storyboard first and hopefully you have an idea of where the application's going and what it's going to kind of do. But I at least wanted to introduce this specific application so you can visualize where we're going, because there is no storyboard, so it's really hard to guess, how this application is going to work and what it's going to do. So now that our application is loaded up, we see that we have a few different views here. This gray area is actually our background view, so we're going to be changing the color of that. And then we're adding a bunch of container views. So we're adding 1, 2, 3, 4 container views. We see that they're different sizes, so we'll figure that out. We also see that we have some labels here, and these are actually image views. We're going to be able to dynamically change and update these. Now, the purpose of this game is going to be able to bet, so we're going to be able to bet 1 up until 5, and then we can spin. And we're going to see we get paid here 5 here, so we got our money back. We got up to 50. We can also just bet max and spin again. This time we lost 5. And basically, if we get we're going to be looking at the rows here, even though we're going to be populating columns, so we're going to have to do some switching around too, which is going to be cool. If we get a flush, specifically we're just going to be checking for colors. So if it's all red, if it's all diamonds, I understand that technically it should be all hearts and all diamonds, but for our purposes we're going to do all the same color. We're also going to do runs, so like 2, 3, 4. And then we're also going to do like 3 of a kind, so like queen, queen, queen will count as payouts for us. I'll just quickly take a look at the structure of this project. We're going to be writing quite a bit of view code inside of our view controller, and we'll go through all of this code together. We're also going to be creating a struct for our slot here, and that's going to allow us to encapsulate the information for each of our slots. We're going to have a factory, and we'll talk about what a factory is and what a factory does. If you're coming from the iOS 7 course, you've seen a factory before, so this will just be another example of a factory. And we're also going to have slot brain. This is where we're going to do a lot of our checking code to see, is a 3 in a row available? Does a flush exist? And what should the payout multiplier be? So we got a lot in store for this project. We're going to be learning quite a bit, so stick with us. So let's get started with our new project. We're going to create a brand new application. We're going to create a new Xcode app. And we're going to choose iOS application, single view application. We could even choose empty. We don't really need the storyboard, but we might as well use the boilerplate code that we're familiar with. So let's name this project Slot Machine. And the organization name and the organization identifier, you can just leave what you have for now. The language is going to be Swift. It's going to be on the universal device. And one of the really cool things about this app is because we're going to be building this all in code, we're going to have this automatically resize to all the different devices that we want to use. So we're going to make sure we have universal selected. We're going to uncheck the option for core data if you have that currently selected, because we're not going to be using core data inside of this application. So we can go ahead and press next, and I am going to create a Git repository on my Mac, so we can create this. And I'm going to go ahead and enlarge my project. Oh, it wants me to allow it, so I'll go ahead and allow it there. So the first thing we're going to do is we're going to go into our view controller. And in this video, we're just going to start setting up our properties here. Specifically, we remember that we have 4 containers. So let's go ahead and add 4 properties. Now we're going to say var first container. And we'll specify this is going to be of type UI view. And we'll add our exclamation point at the end here. Now, adding the exclamation point specifies that this UI view is going to be an implicit unwrapped optional. And basically what that means is normally when we declare properties, we add a question mark when we need to make it an optional. Specifically, if the instance can be nil, or the variable first container can be nil. However, in our case, we're always going to be giving first container a value. And after we set its initial value, we're never going to get rid of first container or set it to nil because we always want a first container on our screen when we're showing this view controller. So we add this exclamation point to specify that. This is also going to be the case when we add our second container. And again, we'll specify that this is going to be a UI view. And we're going to also do this for our third container, as well as our fourth container. And I gotta fix that UI view in just a sec. Lowercase for both of those W's, so let's make them uppercase. So we've set up 4 properties here. Now, the one thing you might say that looks a little bit different, when we hook up view objects from our storyboard, we have a keyword that says IVOutlet. And that at IVOutlet is generally before our variable. But in this case, we don't need this because this is just a helper to the compiler, which basically says that this property is connected to the storyboard. Well, in our case, we're not going to be connecting anything to the storyboard, so we have no need to add that IVOutlet. Now, one other additional thing that we might want to do here is add a comment. And this will just help us organize our properties because we're going to have quite a few in this view controller. Since we're doing everything in code, the amount of code we're going to have to generate inside of this view controller is going to be much higher than we've had to do in the past. And organizing all of our properties will make it really easy to figure out what each one of these properties does and why we need it. So I'm just going to add a little comment here at the top that's going to call this containers. Now in this video, we're going to start setting up our container views, and we could write this all in viewDidLoad. But in the interest of keeping logic modular as possible and trying to keep viewDidLoad clean, we are going to go ahead and create a helper function. So let's use the func keyword, and we're going to call this setup container views. And the only purpose of this function is going to be to set up our first 4 container views that we've added here as properties. And we'll call this function in viewDidLoad. So it'd be the same thing as writing this code in viewDidLoad, except we're just, abstracting this down. And actually, I forgot to add my parentheses here for my function. So just make sure you do that. So the first thing we're going to do is we're going to set up our first container in this video, and then in the next video we'll set up our second, third, and fourth container. So we'll go a little bit slower for the first one. So in order to do this, we're going to say self.firstContainer is equal to UI view, and then we're going to do frame. Now, this is going to basically create a UI view instance. And if we take a look at our storyboard here, and we go to the object library, we can add a view. So let's drag this into our project. You don't actually have to do this, you just have to follow along with what you're seeing here so you understand what the difference is. We're going to delete all of these elements anyway, so no need to drag this in yourself. I'm also just going to add a quick background color here so we can really see the contrast between these 2 views. Now we say this background view is the super view of this view, right? Our second view here. And we say that this view is a subview of our super view. So this is a subview, this is a super view. If we add an additional view on top of this, and let's make this green this time, we can say that this is a subview of this view, right, our gray view, and this gray view is the super view of our green view here. And our white view is a super view of this view, and this view is a subview of the white view. So these are both subviews, right? But their super view is different, right? This green one's super view is the gray background, and the gray background's view is a subview of the white background. And we automatically get this view added to our project. Now we could add an additional button on top of this, right? And we'd say that the button is a subview of the green view. And the green view is its super view. So we can kind of see that in our scene outline here, and every time we see an indent here, we can see this file or view structure here. The other thing we want to cover here when we're thinking about super views and subviews is the difference between a frame and bounds. And I'll just kind of read off real quick the definition between the two, and then we'll see how that works. So The frame property contains the frame rectangle, which specifies the size and location of the view in its superview's coordinate system. So in each case, we take a look at where it's sitting inside of its superview's coordinate system. So we can take a look here, right? We see that this view is sitting inside of this view here, and this view is sitting inside of this view is sitting inside of this view. So it's taking a look at only the super view, not the actual background view. It doesn't look at that coordinate system, it only looks at the super view's coordinate system. And that's we can figure out a view's frame property. And the frame property gives us access to the x, y, width, and height properties. And it basically defines where this view should appear inside of its super view's coordinate system. The bounds property, which is the other property we're going to be accessing and using quite a bit when we create our views in code, which we're going to get back to in just a second, contains the bounds rectangle, which specifies the size of the view and its content's origin in the view's own local coordinate system. Right? So it doesn't look at the super view, it only looks at its own coordinate system. And this is really handy when you want to say, like, okay, what are the bounds of this button? Well, the x and y would be 0, 0, and then the width and the height would be the same thing as the frame, right? So it's really just looking at the placement of this button, and is it relative to its super view? If it is relative, we're taking a look at the frame. If it's relative to itself, we're taking a look at the bounds property. So hopefully not terribly difficult. I know it might seem a little bit confusing, but we're going to go over these examples together when we write and create our view objects, or instances. So we'll have a lot of chances to practice with that. So I'm just going to delete this. We don't need this example inside of our project. And we go back to the view controller here. So the next thing we want to do is we want to set the view's frame. And we just said the view's frame was relative to its super view. So we're going to make a cgrect, so we can use this nice function, cgrect make. And we have to pass in 4 parameters here. It's cg floats. We can think about them for floats for our purposes, although we will be specifying some parameters or properties later on as being cg floats. So for our x coordinate, we'll just start our x coordinate at the views, specifically our background view, right, which we can access with self.view. We're going to use its bounds property, not its frame. We want it relative to itself. So we're going to be able to say self.view.bounds.origin.x, and we'll also start it at 0, 0 for the y coordinate. Just to get started, we're going to adjust this in just a bit. So we're going to say self.view.bounds.origin.y. Right, this is starting in the view 0, 0, so at the top left-hand corner of our screen. And we're going to also go ahead and give it a width, so we can say self.view.bounds.width. And our height here will be self.view.bounds.height. And basically what this will do is it'll add a view, specifically the first container. Haven't actually added it yet, we actually have to explicitly add it, but we're setting the frame to be the exact size of our background view. Well, we actually want to change this a little bit, and the first thing we want to do is we want to add a margin. So we want to have a 10 pixel margin on the left side and the right side to give ourselves or put our container view a little bit more centered to the screen and add a little bit of contrast between our first container and that background view to just really specify what we're doing here. We're going to be using a constant for that, so we're going to go to the top here and create another property, and we'll call this constants. And the first one we're going to do is we're going to say let k margin for view, and we're going to say cg float. And this is where we're specifying something as a cg float. You can think about this as a regular float for our purposes. We're just specifying this as a CG float because that is the type that is accepted here. Now, why can I say that they're the same thing? Well, a float on a 32-bit system is a float, specifically a CG float on a 32-bit system. However, on a 64-bit system, it automatically becomes a double. So really for our cases, either way, we're going to get a number with a decimal here, which is all that we want. So the other thing you're going to see here that's a little bit different is we use that lowercase k before defining the name of our constant here. And this is a pretty standard naming convention. Not really required, but it'll make it really easy for you to see. Anytime I have a lowercase k, it just means that it's a constant. And I'm using the let keyword here to specify that it's a constant. It just basically means that it's going to be some sort of ratio or identifier that I'm going to consistently use. It's not going to change in my code. Maybe I have some sort of key that I'll be using for a tuple later on, and I'll make that a constant. There's a lot of really nice places you can add constants, and it's nice to add them in a single place because then you can see, okay, these are all the constants I'm using inside of this view controller or maybe this project as a whole. So for our cases, we're going to go ahead and update our x origin point, right? We want to move the x origin point over a little bit. So we'll add our constants. We're going to say margin for view. And then what we want to do is we want to reduce the width, but we don't want to just subtract the margin for the view, right? Because what that would do is it would move our view over 10 points. But then the right side would still be flush, right, with the right side of our background view. So we want to move the right side in a little bit. So we'll multiply that by 2. And if you remember your order of operations, right, parentheses are always evaluated first. So we can actually add a set of parentheses. Here we don't need to, right, because multiplication will occur before subtraction does. But I like to add the parentheses here because it nicely separates, or it says, okay, like I'm subtracting 2 times the margin for the view. So it makes it a little bit easier to read, in my opinion. The other thing that we want to do here is we want to change the height of our first container, right? Right now we've added a nice border to our container, but its height is still the entire height of the background view. We only want it to be a 1/6. So let's go ahead and create another constant. We're going to say let, and we're going to say k/6. We're going to specify this as a CG float as well. And we can just say 1 divided by 6. And if you wanted to be even more explicit, you could do like 1.0 divided by 6.0. That'd be completely fine as well, because then you're actually dividing floats, which is nice as well. So with that in hand, we can now multiply the height of our first container by our constant. So we'll multiply this by k/6, no, not k simplified character, k/6. And this will basically reduce the height of our new frame. Now, the final steps we want to do here is we want to update the background color of our first container so it'll really stand out. So we're going to say self.firstContainer.background color is equal to UI color.red color. And we've set UI color instances in code before, so all we're doing is we're accessing the background color property of our first container and setting it equal to a UI color instance that we have this handy red color specifier that will change the background color to red. We also need to go ahead and add this first container as a subview to our view, right? It doesn't just automatically get added because we create this view instance in code. We actually have to explicitly add it ourselves. So the way we add a subview is we're going to say self.view.add_subview. This is a function. And then we can add self.firstContainer. And this is going to basically say, add the first container view, or this new view, to my background view. The final thing we want to do to test to make sure this thing works is we actually want to call this function. So we're going to say super container views. And actually, now that I'm reading that, that's not what we want to call this. We want to call this setup container views. And now we can call this function in code. Sorry for that. And now we should be able to run our application and see our container appear inside of our application. And we see that we now have this red view that's gotten added to our application, and that there's a 10 point border on both the left and right side. Set up our remaining container views. So we'll start with the second container here in our set container views function inside of the view controller.swift class. And we'll say self.secondContainer, and once again this is going to be a UI view and it's going to need a frame. And we'll use that cgrect function again, cgrect make. And the first thing we want to do is self.view.bounds.origin.x. And once again, we're going to do k margin for view. We'll have a 10-point margin for all of our views, so this is going to be consistent for our third and fourth container as well. The next thing we want to do is we want to set up our y point, and this is going to be first container dot frame dot height. And in this case, we want to grab the first container's frame, and notice that we're using the frame property here because we want to access the first container relative to its super view, even though it's aligned with the top. This will come into play later. So we're going to say first container.frame.height, which will basically set our y point to be exactly the height of our first container, so our second container will be flush with the first container. And then we want to set up the width, so this is going to be self.view.bounds.width minus, and we're going to do k margin for view times 2, exactly what we did before. Notice once again we're using parentheses. And then we want to do the height here. So our second container is going to be a little bit larger than our first container. So we're going to say self.view.bounds.height. We're going to multiply this times 3 times k sixth. Now you might say, like, why didn't you just do 1/2, right? 3 times a sixth is 1/2. But I just want to reuse this constant rather than generating a new constant here. I could generate a constant for 1/2, but I like the idea of having a sixth, 3/6, and then we're going to have 2 more containers that are going to both be a sixth. So it's really obvious that this sums up to 1.0 or 100%, right? And that is 100% of the height available to us in the view. So once again, we're just making this dynamic based on whatever views bounds we get, right? Be it we get a small iPhone, we get a large iPad, we're always going to be taking a look at the height as a total based on a view, and then we can dynamically, shrink and stretch our containers to meet that size. So the only real difference that we had here besides that to our first container is we're setting our y point to be a bit lower than our first container, right? Because we don't want them sitting on top of each other. We want to move our second container below our first container. Then we also want to set up the background color for our second container. So we can say self.secondContainer.background color is equal to UI color. And this time we'll use a different color. So we'll say this is going to be a black color. And then we're going to say self.view.add_subview. And then we're going to say self.secondContainer. So we're going to add our third container while we're here too. And this is going to start to look a little bit familiar, so bear with me. Self.thirdContainer is equal to UI view. And we'll say frame. And we can say cgrect make. And this time we're going to use self.view.bounds.origin.x, and once again we want that nice border, so we're going to say plus k margin for view. Our y point here is going to be equal to first container.frame.height plus second container.frame.height. And basically what we're saying is we want the y point of our third container to be below our first and our second container. So we just figure out what the height is of the first one, we add the height of the second one, and that's where we're going to start our third container. The next thing we want to do is we want to fill in the width here. So we're going to say self.view.bounds.width. And then we're going to say that the width should be subtracted from k margin for view times 2. And once again, we can add a set of parentheses here, so it's really obvious what we're subtracting. And finally, we need to add height for our third container. So we're going to say this is going to be equal to self.view.bounds.height. And multiply this by our constant k6. And then once again, we need to set up a background color for our third container. So we're going to say self.thirdContainer is equal to, background color is equal to UI color dot light gray color. And then we need to add our third container to our views. We're going to say self.view add subview. We can say self.thirdContainer. And once again, this is very similar. We're just creating a rect for our third container. The real difference here is we're adding the first container's height and the second container's height. And this will drop our third container below our first and second container. And finally, we want to set up our fourth container. So we can say self.fourthContainer. Let me just scroll down a little bit here. Is equal to UI view, and we're going to say frame. Let me subtract, okay. And we're going to set up the frame is going to be CG rect make, and we can say this is going to be equal to self.view.bounds.origin.x. And the y point, well, we want to drop this below our first, second, and third containers. So we're going to say first container.frame.height plus second container.frame.height plus third container.frame.height. And we need to set our width up here. So what should this be? Well, it's going to be the same thing as our first, second, and third containers. So we're going to say self.view.bounds.width minus 2 times k margin for view. And our height here, I guess I did that a little bit backwards from the way we've done it before, but remember it's multiplication, so it doesn't matter if we do k margin for view first or times 2 first. And then finally, we want to set up our height here. And this is going to be equal to self.view.bounds.height times k6. And I need one more parenthesis there. So what am I doing here? Well, I'm making sure that my fourth container starts after my first, second, and third containers. So that's first, second, and third. That's why I have to add each one of these heights. I have my margin set up the same way for my x and width. And then finally, I'm saying the height is going to be equal to the height of my background view multiplied by a sixth. So we have 1/6, 2/6, 5/6, right? 3 times a sixth, and one more 6 is 6/6. So I'm using my entire available height for my super view, which is my background view. And like before, I want to set up a background color. So we're going to say self.fourthContainer.background color is equal to UI color. And we'll make this one black color. And then we want to add this. We're going to say self.view.add subview, and we'll add our fourth container here. So let's go ahead and run our application and see what this looks like. So we now see that we have 4 views here. And it looks like we have one little bug here, right? We can quickly fix that. The fourth view here just doesn't have its margin, so we'll just do plus k margin for view. That was a little oversight on my part. So if we rerun this one more time, we'll see that it now sets up properly. So when you're doing this, always run your code. You can check to make sure things are being added when you're making adjustments. It's a nice thing to constantly keep running your app. I caught my little bug there of not adding the margin. And now we figured out how to add multiple subviews to our background view. And then we're going to start figuring out how to start adding some elements on top of each one of our containers. Specifically, we'll be adding things inside of each of these views. Next, I want to set up our first container. Specifically, we want to add a view or subview into our first container here. So we've been able to create this, but we're going to add a label on top of our first container. Well, the first thing we want to do is we want to go ahead and create a property, which is going to allow us to define what this label is going to be. So let's just add a comment here. We'll say top container, and we'll say var, and we'll call this title label. This is going to be the title of our project. And this is going to be a UI label. We'll add our exclamation point at the end here. Once again, we're going to create a function to set up our first container. So let's just go down below our setup container views, and we can say func setup first container. And once again, the reason we're doing this is just for cleanliness of code, right? We could write all of this code inside of the setup containers view. That'd be completely fine. We could also write it inside of view did load. I'm just going to abstract this or modularize this into a nice helper function so we can call this and just kind of keep everything a little bit cleaner. So we actually want to add a parameter here. And because this is a property, our first container, we could access this self.firstContainer, but I prefer to pass this in as a parameter. So we can say container view, and we'll specify that we're going to be passing UI view instance in as a parameter to this function. So let's set up our title label. We're going to say self.titleLabel, and we'll just instantiate it. So we're going to say UI label. And now that we have the instance of title label set up or created, we can now set its text property. So we can say self.titleLabel.text is equal to superslots. And this is very similar to what we've done in the past, except that we haven't had to create the UI label instance. But we have created instances of many different classes before, so this is just the normal way that we can create an instance, in this case of a UI label, and we're just setting that equal to self.titleLabel. And we remember that labels have the text property, so we can set it equal to superslots. We also remember that title labels, or just labels in general, can also have text color, right? We can change the color of our text. So let's make this yellow, UI color.yellow color. This will contrast nicely with the red color of our first container. And then we're going to say that we can set up the font here. Now we haven't done this before, I don't believe, so we're going to say self.titleLabel.font is equal to UI font. And then we're going to say name, and then we can say marker felt -wide, and the size will set to 40. And here we're just accessing the font property of our title label, and we're going to make our own font. We're going to choose our own font, and we've done this in the past with our attributes inspector, but we can choose this in code here. So we're going to make it marker felt -wide. And we're going to specify the size is going to be 40. We want a nice large title here. Now, it's really hard for us to predict how large our label needs to be. When we're in the storyboard and we adjust the font size and the font, it will automatically resize the label for us. And we can actually do that in code so that the label will fit the amount of text and the size of our font as well. So the way we do that is we can call this nice function. So we're going to say self.titleLabel, and we'll call the function size2fit, and this will automatically resize our label nicely for us so that the label will be large enough for our text. And then what we're going to do is we're going to say self.titleLabel.center is equal to container.center, container view.center. And this is pretty cool. It's a really cool way that we can dynamically decide where, in fact, my title label should sit inside of its super view. We're just going to basically say, find the center point of my container view and make that the same center point as my title label. So finally, I want to go ahead and add this title label to my container view. So I can say container view.add subview, and we'll add my title label to it. We need to call this function in order for this code to evaluate. So right below setup container views, after we have our first container properly set up, right? Order is very important here. We can say setup first container, and we'll pass in self dot first container. And notice that I'm just passing in my property here, right? I could have just said self.firstContainer.add subview, right? That's why I really said this parameter was completely optional. But I think it's really nice to be explicit here and have access to the container that I'm going to be using when I call this function, rather than having to figure out which property I'm going to be accessing later on. Now we want to set up our second container. This is going to be slightly more complicated than our first container because we need to add 9 image views to our second container. So let's start. The first thing we're going to do is we're going to create a new function. And once again, the purpose of this function is just to try to keep both view to load and setup container views, as clean as possible and modularize things. So we're going to go ahead and create a function. We're going to call this setup second container. And once again, this is going to take a parameter. We'll pass in a container view, and it'll be of type UI view. And we can add our curly braces. And once again, we're going to be passing in a container view. Specifically, this time we're going to be passing in the second container view when we call this function. So what we're going to do is we're going to use 2 for loops in order to generate 3 columns. And each column is going to have 3 different slots inside of it. For now, we're going to be populating 3 image views inside of each one of our columns. So we need 2 for loops. Each for loop is going to run 3 times. So let's create 2 constants. And we can do this in our constant section. And the first one we'll say let k number of containers. And we'll think about that as a column of slots equal to 3. And we can also create a second constant. We'll say let k number of slots, and this will be the number of rows in each column, and we'll set this also equal to 3. So the reason we're going to just create 2 constants here, we could just insert 3 into our for loops, but once again, let's say we wanted to add a 4x4, it'd be really quick to change it here rather than having to go find it in the code. Really nice to set up these constants, and it looks pretty clean. We're going to create 2 for loops inside of our setup second container function here. So let's create our first for loop. So we're going to say for var container number equals 0, and then we're going to say our container number must be less than the k number of containers. Let's make that plural. So let me just adjust my constant here. That sounds a little bit better. So k number of containers, and then finally we'll say slot container number, excuse me. And then we can add our curly braces here. So each time we run through our for loop, we're going to add 1 to the container number, and we're going to say it's going to start at 0. The next time container number will be 1, and finally container number will be 2. So we're going to create 3 different containers, specifically 3 different columns. And next we want to create 3 different rows in each column. So let's add another for loop. So we can say for var slot number equals 0. And we'll say slot number must be less than k number of slots. And then we'll do plus slot number. And we can add our curly braces. And then what we want to do is we want to create an image view. So we'll say var slot image view is equal to UI image view, and we'll add our initializer here. So each time we run through this first for loop, we're going to run this for loop 3 times. And then the second time we run through our for loop, we're going to run this for loop 3 times. And the last time we'll run it 3 times again. So we're going to run this for loop, specifically this line of code where we create this slot image view 9 different times, which will allow us to populate 9 different image views inside of our second container. Well, let's set up our slot image view. For now, let's just set a background color to make sure that this works. So we're going to say slot image view dot background color is equal to UI color, and we can just do like yellow color for now, just so we can see it. Then we also want to set up the frame for our slot image view. Now this is going to be a little tricky, so stick with me. We're going to say slot image view dot frame is equal to cg rect make, and then we're going to say container view dot bounds dot origin dot x plus container view dot bounds dot size dot width times cg float, and we're going to do container number. Finally, we want to create one other constant, so we'll scroll to the top here, and we'll add this right below our ratio constant here. So we'll say let k third, and we'll make this a CG float so we don't have to do any conversion, and do 1.0 divided by 3.0. Right, so it's a third, and we'll multiply this by k third. So what's going on here? Well, we're saying, okay, start off at 0, 0, right, based upon our container views, bounds, origin, x point. And then we're going to figure out if we need to move across the x-axis. Well, how much should we move over? Let's add some sort of value here. In fact, if we want to, we could add a set of parentheses here to make this a little bit easier to read. And we'll say, okay, what's the farthest we can slide over? Well, the farthest we can slide over is the entire width of our container view, specifically our second container. So remember that we're starting with container number 0. So if it's 0, we're saying don't slide over at all. Multiply the width by 0, so that's 0. If we're at 1, right, we want to move over a third of the way, right, because it'll be the width times the container number, which will be 1, times a third, which will give us a third. And then finally, if we're at container section 3, right, the container number will be 2, so we're going to do 2 times a third times the width, which will give us where our third column should originate. So now we want to set up our origin for the y, like how far down should this row be. So we're going to say container view dot bounds dot origin dot y plus container view dot bounds dot size dot height times cg float. We're going to do slot number, and then we'll multiply this by k third. So we're doing a similar set of logic here to our last bit of code. So hopefully going over this again will help you figure out, okay, this time we're going to be moving down instead of to the right. And specifically we're going to say, okay, so for our container views bounds origin dot y point here, start at 0, 0. Start at the top left-hand corner of our second container, and then we'll move down from there. So we're going to say, how far should we move down? Well, the max amount we can move down is the container view's height, right? Bounds that size, that height gives us the maximum height we can move down. That will put us at the very bottom of our second container, so it wouldn't show up. So we know that we want to have 3 rows in our second container. So we have our third here, right? We either want to be at 0, 0, or we want to move down a third of the way or 2/3 of the way. And once again, we can add a set of parentheses here. We want to make this a little bit easier to read. Just remember that we're multiplying either a third times the height, or 2/3 times the height, or 0 times the height. And that will figure out how far y should be. So as you can see, as we're iterating here with our 2 for loops, we're going to be able to populate all 9, and they're all going to have different either x or y values, right? We're never going to have 2 different image views that have the same frame for the x and y. So the final thing we want to do is we want to set up the width and the height of our image views. So the first thing we're going to do is we're going to set up the width, so we can say container view dot bounds dot width. We'll multiply this by k third minus 2. And then we're going to set up the height, and we'll say container view dot bounds dot height times k third times 2. And, excuse me, minus 2. So what's going on here? Well, we're going to start off by figuring out, okay, what is the maximum width that our image view could be? Well, it shouldn't be bigger than our container view, so it's a good place to start with the width. And we want to multiply the size, the maximum width, times a third, and we're going to subtract 2 from that. Well, why are we going to subtract 2? We're going to actually refactor this in just a second. Let's take a look at the third first, and we're basically going to say, okay, let's divide the total width into thirds, and that should be the size of each container, right, or each slot that we're going to be showing off. And we're going to do the same thing for both the width and the height. Now, the 2 here is just going to give us a nice little border, so we're going to be able to see the differentiation between all of our image views. So we're just going to subtract 2 from both the width and the height to give us a little bit of a margin. And let's go use a constant. Again, this is another great place to use a constant. So we could say, let's do this right below the margin for view. We're going to say let k margin for slot. We'll make this a CG float, and we'll set this equal to 2.0. So let's just do a little bit of quick refactoring here. Let's use the constant again, and the constant again. So we've now set up the frame. I know this is quite a bit of code, so hopefully you're able to stick with me, and we'll see what it looks like in just a second. But the final thing we want to do here is we want to actually go ahead and add this to our second image view. So what we're going to do here is say container view dot add subview, and we'll add our slot image view. And we're going to have to do some refactoring later to properly add an image to our image view. But for now, let's actually go ahead and call this function, set up second container. Let's just do this in view.did_load for now. We're going to actually do this in a different place later on, but we can say self dot second container in view.did_load, right? We're just going to call this function we created, and we're going to pass in our second container so we can properly set this up. And all we're doing is we're going to add each image view to our container view, and our container view is going to be the second container. And we can go ahead and run our application here. And we see that we now have 9 different image views that are appearing here. We set the background color to yellow, and because we added that little bit of a margin, we actually can see that black background we set up for our second container, so we get some differentiation between each one of these slots. I'm going to start setting up our third container, which is going to hold 6 labels, and in this video we're only going to have time to add one of the labels, but we'll add the helper function that's going to be responsible for setting up our third container. So like our first 2 functions here, we're going to call this function setup third container. Maybe you could guess that was going to be the name. And then we'll also have a parameter here, container view, and it'll be of type UI view. So we're going to add our credits label. So we're going to be able to identify the number of credits we're going to be currently available to us, or that we currently have. So let's go to the top here, and we can add an additional section here. Let's add a comment. We can call this information labels, and we'll just go ahead and add the labels that we're going to need. So we'll start off with var credits label, and it'll be a type UI label, and we'll add our exclamation point at the end here. We'll set up a bet label. This will tell us how much we're currently betting, and this will also be a UI label. Let me add a space there, just make it consistent. And then we'll also add a winner paid label. So we'll say var winner paid label. This will tell the user how much they won on their last bet. And then we'll add a second set of labels, and this is just going to be a title. It's going to basically say credits, bet, and then winner paid. So we're going to say var credits title label. kind of a title here, and we're going to say it's going to be a UI label. And we'll say the next one's going to be bet title label. And once again, this will be a UI label. And finally, we'll add a winner paid title label. So we'll say var winner paid title label. And this will also be a UI label. So we're adding 6 label properties here, and we're going to have to set these all up in code. But we're going to add them as properties so we have access to them in all of our different functions. And once again, we're not going to be using that IB outlet keyword because we're not connecting up these elements from the storyboard. So let's go down to our function again. We just added a few returns here so we can kind of center this up. And we're going to first start by setting up our credits label. So we can say self.creditsLabel is equal to UI label. And this is just instantiating the UI label instance. The credits label property now has a value. And then we can say that the credits label as text property is going to be equal to 000. Actually add 2 more zeros on there just so we have enough space. The reason we want to add so many zeros is that we're going to be using that size to fit function that we've seen before. And basically we want to space our label so it has quite enough space to show off the information. You know, if the user is really successful in our game, we want them to be able to get into the tens of thousands, right? If they get into hundreds of thousands, their information might not show up properly, and we could recall size to fit. But that's a very easy adjustment to make down the road. So let's also set up a text color here. So we're going to say self.creditsLabel, and we'll say .textColor is going to be equal to UIColor.redColor. And we also want to update the font. So we're going to say self.creditslabel.font is equal to UIFont name, and we'll pass in Menlo bold, and the size will be 16. And you can play with the fonts and the size here if you want it to look a little bit different. The next thing we'll do is we'll say self.creditslabel.size to fit. And once again, that function is just going to enlarge our label's frame so that its height and its width are big enough to display the text that we're going to be showing off here with the font that we've specified. Let's also set up the center. Now, because we're going to have 6 buttons here, we don't want to just center this credits label in the center of the third container. We're going to want to play with this so we can kind of get these arranged in thirds across our container so we can display all 3 kind of equally spaced as much as possible. So what we'll do here is we'll say self.creditslabel.center is equal to cg.make. And this is a little bit different, right? A center here is actually a CG point, so it has an X and a Y, but we are not using a CG rect, right, which also has a width and a height. We're specifying that in size to fit, right, which will automatically determine what the width and the height should be. So all we have to really say is, okay, what should the center of the credits label be? And that center is going to be in an X and a Y point. So in order to do this dynamically, rather than just kind of hard coding this and saying it should be at 20 points for X and 20 points for Y or something like that, we're going to say container view.frame.width times k6, and then we'll say that the height should be container view.frame.height times k third. And let's add a space here. And basically what we're going to do here is we're going to divide our container into 6, and this will give us enough space to get everything in there for our X coordinate, and then our Y will just divide this into thirds because we only are going to have two rows, right? But we're going to have 3 columns, right? So we need equal space. So we're going to divide this up into 6, and every other will drop a label in, right? So this will space it nicely for us. We also want to go ahead and add a text alignment here. So we're going to say self.creditslabel.text alignment is going to be equal to ns text alignment, and we'll say dot center And this will essentially align our text to be centered, and this will be great because if we put in 1, for example, it'll display in the center of this label, even though we're going to be spacing this label to be quite large initially because we're going to be putting so many zeros. We also want to change the background color to give our label some sort of real identifier and some contrast against this third container. So we're going to say self.creditslabel.background color is going to be equal to UI color.dark gray color. And then we can say container view.add subview, and we can add our credits label. So we can go over our code real quick again. We're setting up our credits label by instantiating an instance of UI label. Then we update the text, and we're again making this quite large so that our label will have quite a bit of space to add additional values in the future, and we'll be able to display those. So our user could potentially win up to 99,000 credits in our game. We're going to update the text color. We're going to set that equal to red. We're also going to be updating the font, and we're going to use this UI font instance here. And we can pass in a name parameter and a size parameter here. So we pass in a string. It's going to be Menlo bold, and the size is going to be 16. We're also going to call the function size to fit, and this is going to go ahead and auto resize our label to fit our text and our font here. So it's going to determine the width and the height. We're also going to set up the center, and this is going to be essentially be the coordinate where we're going to draw our credits label. And we're going to use a CG point because center is a CG point. It's an X and a Y point instead of CG Rex like we've seen in the past, which had an X, a Y, a width, and a height. So we divide up our container view's width and multiply that by a sixth. And then we're also going to divide up our height and divide that by a third. Then we also are going to determine that the text alignment should be centered. So we're going to specify that using NSTextAlignment .center. And then we're also going to set a background color, and it's going to be dark gray. And finally, we're going to say container view add subview. We're going to call this function add subview, and we're going to add our credits label to the container view. Specifically, we're going to add it to our third container. We can call this function now in view.load. So we're going to say setup third container. We're going to say self.thirdContainer. And we can go ahead and run our application here. I'm just using the iPhone 5S. And we see that now we have a label here that's displaying 6 zeros for us. Let's now set up the bet label and the winner paid label. So we're going to start once again in the setup third container function. And the first one we're going to do is self.betLabel. And we're going to say this is going to be equal to a UI label instance. And then we can say self.betLabel.text is going to be equal to, we can just put 4 in this time. And the reason we don't need such a large text for our bet label is we're actually going to only allow our user to max bet 5. But we'll add a little bit extra in there in case we want to up our max bets in the future or something like that. We can say self.betLabel.textColor, and we'll set this to be equal to red once again, so we do .red color. And then we can do self.betLabel.font, and we can say this is going to be equal to UI font. And we'll say name, and it'll be Menlo-bold, and the size will be 16. And then we can update the size of our bet label, so we'll say self.betLabel.size-to-fit. Right, and this will automatically determine the width and the height, the same way we do with our credits label. And we next need to set up the center like we did with our credits label. So we're going to say self.betLabel.center. It's going to be equal to CG point make. And we're going to do container view.frame.width times k6. The way we did before, but let's multiply that by 3 this time because we don't want the bet label center to be on top of the credits label. We're going to move it over 2 slots. So that way there'll be some spacing in between our credits label as well as not being right on top of it as well. We also need to set up where the Y point should be. So we're going to say container view dot frame dot height, and we'll multiply this by k third. And the same way we did for our credits label. Let's also set up the text alignment of our bet label. And we'll make this center, so we can say ns text alignment dot center. And then we're going to also set up the background colors. So we can say self.betlabel.background color is going to be equal to UI color dot dark gray color. And then let's add this. So we can say container view dot add subview, and we can add our bet label to it. Let's also set up the winner paid label in this video, and we're going to say self.winner paid label. And this is going to be very consistent with the last two labels that we've done, so I'm going to move a little bit faster. So I'm going to say self.winner paid label. We have the instance now, so we're going to say its text property is going to be equal to, and once again, we're going to do our 6 here because our payouts can be quite large if the user kind of hits a jackpot, and we'll get into what all the multipliers are in the future, but let's just give ourselves enough space to work with. And then what we're going to do is we're going to set up the text color, so we can say self.betlabel, winner paid label dot text color, and we'll say this is UI color red color again. Now, if you want to change some of these colors, feel free to do so. Totally encouraged. If you want to really make this app your own, go for it. We're also going to set up the font, so we're going to say self.winnerpaidlabel.font, and we'll set this equal to UI font name, and the name will be once again Menlo bold, and the size will be 16. And then we're going to say self.winnerpaidlabel.size to fit, and then we're going to say self.winnerpaidlabel.center is going to be equal to cg point make, and then we're going to say container view dot frame dot width times k6, and we're going to multiply that by 5. So we have 6 kind of different sections here, and this is the third one. So we did starting at 1/6, then we did 3/6, and now we're doing 5/6. So each label is separated, and they all have spacing in between the labels. We also need to put in the Y point here, so we're going to say container view dot frame dot height times k third. And then what we need to do is we need to set up the text alignment. So we're going to say self.winnerpaidlabel.text alignment. And we can say this is going to be ns text alignment.center. And we can say self.winnerpaidlabel.background color. And this is going to be UI color dark gray color. And then finally we need to add this to our container view. So we're going to say container view, add subview, self.winnerpaidlabel. Let's set up our final 3 labels for the third container. And once again, these are going to be very consistent to the way we've set up our previous labels. So I'm going to go through them a little bit quicker, just in the interest of time and getting through this stuff. Now, we are going to be changing the font, and we're also going to be moving the Y point a little bit lower than the Y points we had for our first 3 labels, because we want these to display below the labels we've already created. Also, we're not going to be dynamically updating these. We're just going to kind of make them static. So we could have just made these local instances, but I like to keep them as properties just in case you wanted to update them in the future. You'd be able to access them from any function. Also, I know that there's going to be a huge desire for some of you to just copy and paste this code in. And if you're really familiar with what you're doing, that's great. But if you're just starting out with this course, you've never coded before, you've never coded iOS, I really recommend that you type this stuff in. Believe it or not, actually getting some sort of name recognition here, typing in yourself, getting used to being very careful with syntax and all that stuff is good. And that's why we actually create so many labels, so you have so many chances to see this thing over and over again rather than just creating one and assuming you fully understand it. So with those facts out of the way, let's just jump right into this. We're going to say self.credits title label and we have to instantiate it. So we're going to say UI label. Then we'll create the instance of our credits title label. Next, we want to update the text. So we're going to say self.credits.title.label.text. It's going to be equal to credits. Then we want to update the text color. So we're going to say self.credits.title.label.text color. And we're going to make this black this time. So we're going to say UI color.black color. Next, we'll set up the font. So we're going to say self.credits.title.label.font is equal to UI font. And then we'll do custom initializer here. So we'll put in the name, and then it'll be American typewriter. Very important that you get the spelling exactly the same way I have it here, or your font won't work. And we're going to do size 14 for this. We also want to make our credits title label stretch. So we're going to say self.credits.title.label.size to fit. And then we're going to also set up the center for our credits title label. So we're going to say self.credits.title.label.center is equal to, and then we can make this a CG point. So we'll do CG point make, and it'll be container view dot frame dot width times k6, and the y will be container view dot frame dot height times k third times 2, because we want to move this a little bit farther down than our previous credits label. So we want it to be below it, so we'll multiply this by 2 to move it below it. We also want to add this credits title label to our container view, so we'll say container view dot add subview, and we can say self.credits title label. We also want to set up our bet title label, so we'll say self.bet title label, and we're going to instantiate this. So we're going to say UI label, and then we need to set the text property for our bet title label. So we'll say self.bet title label.text, and we can set this equal to bet. And we need some text color, so we'll say self.bet title label.text color, and we can set this equal to UI color.black color. And we need some fonts, so we'll say self.bet title label.font, and we'll set this equal to UI font name, the American typewriter again, and the size will be 14 again. And we also want to use size to fit again, so we'll say self.bet title label.size to fit. And we need a center, so we'll say self.bet title label.center is equal to CG point make, and we'll say container view.frame.width, and we'll do times k6 times 3, because we don't want this to appear on top of the credits title label. We want it to be to the right of that. But the y point should be the same as our credits title label, so we'll say container view dot frame dot height times k third times 2. And then we need to add this to our container view, so we'll say container view dot add subview, and we'll say self.bet title label. We also want to set up our winner paid title label, so we'll say self.winner paid title label, and we'll instantiate this, so we'll say UI label, and then we can say self.winner paid title label dot text is equal to winner paid. And then we want to set up the text color, so we'll say self.winner paid title label.text color is equal to UI color.black color. And then we want to set up the font, so we'll say self.winner paid title label.font is equal to UI font name. It'll be American typewriter again, and the size will be 14. And we need this to size to fit again. So we'll say self.winnerPaidTitleLabel.size to fit. We'll call that function. And then we need to set up the center. So we'll say self.winnerPaidTitleLabel.center is going to be a CG point. So CG point make container view dot frame dot width times 5 times k6, and our y will be container view dot frame dot height times 2 times k third. And then finally we want to add this, so we're going to say container view dot add subview, and we'll say self.winnerPaidTitleLabel. So let's check to make sure this worked. Hopefully there aren't any bugs, but we'll see in just a second. And we now see that we have all our labels. We see that they're spacing really nicely, and they're all appearing inside of our container view. We're going to be setting up our fourth container now, which is going to have a bunch of buttons, and we're going to figure out how to create UI buttons in code. Now this is a little bit different than creating UI labels in code, so pay attention closely and follow along as we get started. The first thing we want to do is we want to create a new function, and we'll call this setup fourth container. And we're once again going to pass in a parameter called container view, and it'll be a UI view instance. So we need to add some properties for our buttons, so we'll be able to access them in all of our functions. So let's go right below information labels, and we can add another comment here. It says something like buttons in fourth container. And we want to add 4 buttons. So the first button is going to be a reset button. So we can say var reset button, and this is going to be of type UI button, and we'll add an exclamation point at the end. And then we'll also do a bet 1 button. This will allow the user to bet 1 credit. And we'll say var bet max button, and this will allow the user to bet the maximum amount. We're going to set that to 5 later on. And then we want a spin button, right? We actually want to be able to spin the slots and see if we win or not. So we have 4 properties here. We need to set up 4 buttons. We're only going to set up one of these buttons in this video, and then we'll set up the others in the following videos. So the first thing we want to do is we want to set up the reset button. So we can say self.resetButton is going to be equal to UI button instance. Now this works very similar to setting up a UI label instance, right? We're just creating the button. Although we haven't set any text for it, it's not tappable yet. We haven't done anything with this button yet, but the instance now exists and we can start setting it up. So the first thing we want to do is we want to set up a title. So we're going to say self.resetButton, and we don't have access to something like text, right? Like for our labels, we just access the text property and it updates. We actually have to call a function here, and the function is going to be setTitle, and it's going to accept 2 parameters here. The first one is going to be the title that we want, so it's just going to be a string, not too difficult. But then we also have this thing called control state. Now buttons can have different control states. They can be currently selected, they could be highlighted. We're just going to use normal, and then this will allow us to use our button properly. We'll get more into control states way in the future. For now, normal is going to work perfectly for our needs. But if you're interested, you can take a look at UI control state pretty easily in Apple stocks. So we're going to go to UI control state here, and we're going to do .normal. And it actually, even if we hold down the Alt key, will give us a nice little indicator, the normal default state of control that is neither selected nor highlighted. So it's just like the default state for our button. The next thing we want to do is we want to set up some title color. So we're going to say self.resetButton, and we're going to do set title color. And once again, we could have different colors for our title based on whether or not it's selected, right? Like maybe if you're holding down, you make it blue, and if it's not being held down, it's green or something. But once again, we're just going to use this default UI control state of normal. So let's first pass in a color. So we're going to do UI color.blue color. And for state, UI control state, and then we'll do .normal. We can also set up a custom font for our button. So we're going to do self.reset button. Now we're actually going to access a property of our button, and that's going to be the title label. And buttons automatically get a title label added. However, this is going to be an optional because we don't set a title, right? It doesn't exist, but we can access that property once we set a title. So we've already set a title. We're going to have access to this. We can now set up the font. So because it's an optional, we have to put the question mark here, and then we're going to do .font, not .frame, .font. Set this equal to UI font name, and the name is going to be Super Clarendon. I hope I pronounced that correctly. Dash bold. And let me just double check here. Clarendon. Yep, that's spelled correctly. And then we want to also put the size in here. We'll do size 12. Now, one thing I want to point out here is that we set the title color with this function set title color. You might say, why don't we do self.resetButton.titleLabel.text color? Because this is a label property, right? Why can't we just access the text color? And the reason we don't do that is if we hold down the Alt key and we look at our title label here, we see that Apple explicitly tells us to not do that, right? It tells us to use set title color for state. And that way we're going to be able to update the title color for state, because if we just accessed the text color directly, we wouldn't be able to set the state for our label here. So it's a little bit of optimizing Apple's doing in the background, and I highly recommend that you stick with this pattern. And the other thing we're going to want to do here, we have a few more attributes we want to set up here, is we want to set up a background color for our button. So we're going to say self.resetButton. Background color is equal to UI color light gray color. And we're also going to use that size to fit function. So we're going to say self.resetButton.size to fit. And like our label, size to fit is going to automatically stretch and optimize the width and the height to fit the text that we've set up here. So we've set up the title, and now it's going to be able to properly size it for us. So like our labels, we now just need to set up a center. So we're going to say self.resetButton.center. Before we set up the CG point for a center, we're going to want to create two constants. So let's scroll to the top here. And we're going to make a constant for k-half. And we'll say this is going to be a CG float. It'll be 1.0 divided by 2.0. And we're going to do let k8th. And we're going to set this equal to CG float. We're going to set this equal to 1.0 divided by 2.0. So with those two constants in hand, we can go back to our center here, and we can set this equal to CG point make, and it's going to be container view.frame.width times k8, and our y is going to be container view.frame.height times k-half. And actually I see here that I have a typo, so it should be E-I-G-H-T-H. Let me just fix that quickly here when I get this spelling incorrect. So I've revised that constant name, sorry about that. And what we're doing right now is we're just setting up the center. So we're going to say that the x, we're going to divide up our container into 8 equal lengths, and we're going to drop our reset button an 1/8 of the way into our container. So it's not going to be flush with the left, but we're still going to have space to add our other 4 buttons. We also want to go ahead and drop our button halfway down in our container, so we're going to use that k-half constant we set up. The other thing we need to do here, and this is going to be very different than what we've got for our labels here, is we're going to actually have to add some target action. Target action can be a little bit tricky the first time you see it done, but we're going to do this together a few times, and hopefully it won't seem too scary by the time we're done. So let's just go ahead and do this. We're going to say self.resetButton dot add target, and we're going to say that the target is going to be self, and the action is going to be reset button pressed. It's going to be a string, so we're going to say reset button pressed, and we're going to add a colon at the end here, and then we're going to say for control events UI control events dot touch up inside. Well, what are we doing here? We are saying that when the button is tapped, we want to call a function on this inside of this current class, right? So we're going to pass self in. We don't want to call this function in another class. We want to call it in this specific class. And the function that we want to call is named our action here, and the action is going to be reset button pressed. Now notice this colon here. The colon says that I'm adding a parameter to my function here, and specifically I'm going to be passing in the instance of UI button. And we've done this every time we've set up IB actions in the past, right? It's always had some sort of parameter. So by adding this colon here, we're specifying that we will have a parameter. Now we could have multiple parameters, that'd be fine. The colon just specifies there will be one or more parameters. And what that means here is if we don't add a function named reset button pressed, when we press this button, our application is going to break. So we got to be very careful when we add this target action to our project. The final thing we're doing here is we're saying, okay, what type of touches are we going to look for? Well, we're going to look up for touch up inside, right? And that's just like our default touch that we look for when we set up IB actions. Now, let's go ahead and add this reset button pressed function right away so our application has no risk of breaking. All right. So I'm going to do this right below the did receive memory warning and right above the setup containers. I like to group my IB actions. So we can add a comment here. We can say something like IB actions. So we can group these all together. And what I recommend you do so that you never put the wrong syntax in and it doesn't cause a break, I recommend you actually copy and paste this function name. So we're going to copy the string here. I'm using Command C, and then we're going to write func, paste in our function name. We're going to add a parameter. It's going to be named button, and it's going to be of type UI button, and we'll add our curly braces. So now when we press our button, we'll be able to have the code inside of reset button pressed evaluate. In fact, let's add a print line statement here because we're going to run our application in just a second and prove that this is working. So we're going to say reset button pressed. And target action is really common. One way you can think about this is when something occurs inside of our application, specifically when we tap this button for this specific control event, what is the target? Like what class should do something? And the target is going to be this current view controller, right? Needs to do something. And what does it need to do? Well, what is the action it needs to do? It needs to call the function reset button pressed, and that will evaluate the code that we set up here inside of our IB action. So that's basically what Apple's generating when we hook up these buttons. The final thing we want to do here is we want to actually go ahead and add our button to our container. So we're going to be able to say container view dot add subview, and we'll add self.reset button. So let's go ahead and call this function setup fourth container. And we'll do that in view did load to, and we have to pass in our fourth container and run our application and see if this button is in fact working. So we're going to press the reset button here. We're going to see reset button pressed is printing to our console. One little bug here, and that's right now our button is appearing in the middle of the screen. It should be on the far left, and I believe that's because there it is. Our constant should actually be 1 divided by 8.0, not 1 divided by 2.0. That's my fault. So just adjust that, and you can rerun your application here. And we'll see that the 8th now works properly, and my button is now appearing on the far left. So every time I press my button, the reset button pressed, function is going to evaluate, and right now all we're seeing is the console printout for the reset button pressed function. We're going to slowly set up our second button here, and then in our next video we'll set up our final two buttons a little bit faster, just so you can really get used to this process of creating UI buttons in code. So let's set up our bet1 button. So we're going to say self.bet1 button, and we're going to instantiate this. So we'll say u is equal to UI button. And now that we have our button created in memory, we can say self.bet1 button dot set title, and we need to pass in a string here. So we're going to say bet1. And for state, we're just going to use that UI control state normal again. Remember, we don't want to worry about selected or highlighted. We just want the default state for our button here, and that'll be the title. And that will default throughout. So if it's selected, unselected, the title will be bet1. We also want to change the title color, like we did with our reset button. So we're going to say self.bet1 button dot set title color, and we're going to set the color to be UI color dot blue color, and the control state will be UI control state dot normal. Next, we can set up the font for our button. So we're going to say self.bet1 button dot title label, and we'll do the question mark. Remember, this is an optional, right? Our title label doesn't automatically exist. We have to create it. That's why we set it up here. And we're going to access the font property, and we're going to say it's equal to a UI font instance. And the name is going to be the one we had before, the super Clarendon bold. So I'm just going to copy and paste that in. So we'll make sure we get it in there correctly. And the size will be 12. We also want to set up the background color. So we're going to say self.bet1 button.background color. We're going to set this equal to a UI color instance. And we're going to set this equal to green color. We're going to have a green background. We also want to resize this bet1 button. So we're going to say self.bet1 button.size to fit. And this will automatically readjust the height and the width of our button. We also need to set up the center. So we're going to say self.bet1 button.center. And we're going to set this equal to CG point make. And we'll say container view dot frame dot width times 3 times k8. And we also need to set up the y. So we're going to say container view dot frame dot height times k half. And then what we want to do is we want to add some target actions. So we're going to say self.bet1 button dot add target, and the target is going to be self, and the action is going to be bet1 button pressed. And the control events are going to be UI control events dot touch up inside. And then we're going to say container view dot add subview, and we're going to say self.bet1 button. So let's quickly just review our code here before we go and set up the bet1 button pressed function. And the first thing we're doing for our self bet1 button property that we set up earlier is we're actually setting it equal to an instance of UI button. Then we're setting up the title, and we're setting it for specific control state. Specifically, we're just going to use normal, which is the default. We then set up the title color. We're going to make it blue this time. We actually made it blue last time as well, so that'll be consistent. And once again, we're using the same control state, UI control state normal. We're going to set up a font, so we access the title labels font property, and we're going to use this super Clarendon bold, and the size is going to be 12. Next, we're going to set up a background color. We're going to make it green this time, and that is going to be different than the light gray we had before. And then we're going to stretch our button, the height and the width, to fit our font and the size of our font as well as the text we chose. And that's going to be occurring in the size to fit function that we're going to call on our button here. We're going to set up our center, and we're going to move it a little bit to the right. So we're going to multiply this by 3 to the k8 times 3. But we're going to have the same y, right? We're going to move it halfway down in the container. We're going to add a target here, and once again, the target is going to be on this current view controller. We're going to have to implement a function named bet1buttonPressed. Remember, the colon here says there will be a parameter, and we're just going to pass in the button itself. And then for control events, UI control events, touch up inside. It's just the default touch event that we want to look for in our button. And then we're going to add bet1button to our container view as a subview. So we need to implement bet1buttonPressed as an IB action. So let's just copy this, and we're going to do this right below our other IB action here. IB action is a little bit deceptive because we're not explicitly using the IB action keyword, but they are actions, right, that are occurring. So it's nice to group these together, and we can call it IB action for our purposes. So we're going to say func bet1buttonPressed, and we're going to pass in button, and it's going to be a UI button type here, or instance. And we're going to pass that in as a parameter when we call this function. Specifically, we'll pass the button in that gets tapped. And then we can test to make sure this works. Let's do a print line statement here. And we're just going to, this time, let's just pass in the button and take a look at what this button is. And we can add an identifier here. We'll say bet1buttonPressed. So let's go ahead and run our application here. And let's press bet1. And we see that the bet1buttonPressed text is coming up, and it's also showing us the button here. We can see its frame and a little bit of information about this button. We could also drill in using the properties of the button, but we don't really need to do that right now. It's enough to know that when we press the button, the correct function is going to work. So now we can have things dynamically occur when we're pressing buttons on the screen. We're done with setting up our views for a little bit. We're going to have to come back to this and make some adjustments in the future. But for now, we're going to get started creating a slot struct. And this is basically going to encapsulate the information that we're going to use to display each of our slots on the screen. Specifically, we're going to be encapsulating a value, an image. We're going to be able to tell if it's red or not, because we're just going to be checking for red or black for flushes. Make it a little bit easier, but we don't have every card in our deck. We're only going to have access to some of the cards. So let's create a new struct. We're going to go to File, New File, and we can select iOS source, and we can choose Swift file. We can choose Next, and we're going to go ahead and call this slot, and we can create this. And then once this thing loads up, we're going to first start by importing UIKit. And this is going to give us access to a UI image that we're going to use as a property in just a second. But the first thing we're going to do is we're going to write struct slot, and we'll add our parentheses. So now we have our slot struct, and we're going to want to add three properties here. So we're going to say var value, and I always like to create my properties with an initial value. So we're going to set this equal to 0. We need an image, so we're going to say var image, and this is going to be a type UI image. And we're just going to set the default to be named. And we could just put ace in for now. We'll be adding images in our next video. We next want to set up a bool, and it's going to be called isRed. We're going to set its initial value equal to true. And then we'll dynamically set that based upon whether or not the card we add is red or not. Now let's add the image assets for our project. We're going to go ahead and add them to our images.xc assets. And this is the proper place to add images. We've just kind of dragged them in the past, and that's worked okay. But this is a much better way to organize your images, because you're going to be able to add the @x and @2x images, and it's really going to fit in properly for Retina and not Retina displays, and be able to identify them very quickly inside your project. So we're going to go to this little plus down here, and we're going to go to new image set. And I like to name my image sets based on the same name as my images that I'm going to be dragging in. So the first one I'll drag in is the ace, and notice that we have both the ace.png and the ace at 2x. So it's important that you have both for the Retina and non-Retina displays here. And we just are going to go ahead and add all of our assets here. I'm going to try to drag these two things side by side here. Go ahead and download these assets if you don't have them yet. So we're going to need to create a new image set for each of these items that we're adding. So we can add 8 next. And let's go ahead and drag in the 8 PNG and the 8 at 2x PNG. Now you're also going to want to make sure the case is the same. I always like to capitalize the first letter when I'm adding assets as well. It's just kind of my habit. So we'll add 8, and then we're going to add 5. And we can do 5 and at 2x. And then we're going to add 4. And we'll do 4.png, 4 at 2x. And we need to add Jack next. And we can do Jack and Jack at 2x. And then we're going to also add King. So we can do king.png, king at 2x. We'll add 9. And we can do 9.png, 9 at 2x. And then we'll add queen. And queen.png, queen at 2x. Almost there, about halfway done. 7 will be next. And 1 and 2. And then we'll add 6. And we can add 6 at 2x. And then we'll be able to do 10. And we do 10 at 2x. And then we're going to add 3. And then we'll do 3 at 2x. And finally we can add 2. Then we'll do 2.png and 2 at 2x. So with these images added now, we're going to be able to access them. We've already done so with the slot by just doing ace. We don't even have to specify the file extension, right? PNG, JPEG, by adding them to the image.xc assets. So that's pretty cool. If we have different image types in here, we won't get those issues that we could have had in the past where you have to specify the file extension. And now as I'm looking over this list, I see both 6 and 7 didn't stay for some reason. So let's just quickly add those back. We'll say 6, and let me just reopen my slot machine assets folder, and we'll re-add 6 to my project, 6 1x, 6 at 2x, and let's also re-add 7 while we're at it. So we'll say 7, and this will be 7.png, 7 at 2x. So that should be them all. Now we need to create a helper class, which is going to be called a factory. And the purpose of the factory is going to be to generate our slots so that we can assign the images for each slot and the value, and also figure out if it's read or not. So let's go ahead and create a new class. Here we can go to File, New File, and we can go to iOS Source, Swift File, go to Next. And then we're going to choose, here we're going to choose a write-in factory. And we can make sure that we have our target selected here and create this. And we'll get an empty class here. We're going to import UI kit so we can have access to UI image. And then we're going to do class, factory, and add our curly braces. So we're going to first create a class function, and a class function is very much like a regular function, except that when we call it on the class itself. So we'd say factory dot whatever the name of our function is, instead of creating an instance of the factory and then calling the function on that instance. Why are we going to do this? Well, there's really no reason to create a factory instance, since we're just going to create a bunch of slots and we just want them back. We don't really need to have a factory instance lying around in memory just taking up space. So it's efficient to do it this way. Sometimes there's even overlap between when you could create a class function, instance method, or an instance function, excuse me. So it's kind of just the art of programming here, when to know when to do which. hopefully you'll be able to see that in this case it makes no sense to have a factory instance, so a class function works great. So in order to create a class function, we're going to use the class keyword followed by the func keyword, and then we're going to say create slots, and this is going to return an array within an array, and it's going to have a slot inside the inner array. So we can add our curly braces. And let's just talk about what an embedded array is for a second here. An embedded array allows us to add multiple arrays into an array. And each one of these arrays inside of it can hold one specific type. Specifically, we're going to have a slot. So we're going to be able to have multiple arrays. Let's say we have 3 arrays, and each array is going to be able to hold 3 slots, and we're going to be able to add all those arrays to a single array that we're going to be able to return from this function. Well, I think the easiest way to figure this out or visualize this is to actually build this out. So let's go ahead and get started creating this. The first thing we're going to do is we're going to create a constant here. We're going to say let k number of slots equal 3. And then we're going to say let k number of containers equal 3. Why do we need 3 and 3? Well, we are going to want 3 slots in each container, and we're going to want 3 containers. And this is hopefully seems very similar to what we set up in our view controller file when we set up our second container, where we had to add 3 containers, k number of containers, and k number of slots. So we're now going to have an array which has 3 arrays inside of it, and each array is going to have 3 slots, and we're going to use these 9 elements to populate all of the image views we set up in our second container. So what we'll first do here is we'll create an empty array. So we're going to say var slots, and this is going to hold an array of arrays, and it's going to hold slots inside of our inner array. And we'll just initialize our array here. And basically we're saying, okay, now this array is ready to go. It doesn't have any arrays added to it yet, but we can add arrays to it now. We can append arrays. So let's use a for loop here. So we're going to say for var container number equals 0. And then we'll say container number must be less than k number of containers. And then we'll say plus plus container number. And we'll add a curly brace. And then what we want to do is we want to create an array of slots. So we're going to say var slot array, and we'll say this is going to hold a slot, and we'll initialize an empty array here. And then we'll say for var slot number, and we'll set this equal to 0. And then we can say slot number must be less than k number of slots. Again, a space. And then we'll say plus plus slot number. We can add another set of curly braces. And then we can say var slot, and we'll just create a default slot for now. So we can just do slot, and we'll just give it some default values here. We'll say 0. The image is going to be equal to nil, and is red. Sure, why not? Actually, we have to add a default image here. So I'm going to say UI image named, and then we can add 2 quotes here. So we're just creating an empty slot. We'll actually create these slots properly in just a minute. We'll actually create a helper function to do that. For now, we just want to be able to finish our function and then go over what we're doing here, because there's quite a bit of code. So then we're going to say slot array dot append, and we'll add our slot here. And then down below this curly brace, we can say slots dot append, and we'll add our slot array to this. And then finally, we can return slots from this function. Excuse me, slots, plural. And this should resolve our build error here. If we go to build, it should no longer compile with an error. So let's go over our code here. There's not tons and tons of code, but it's a little tricky, a little confusing what we're doing here. We have 2 for loops, we have an embedded array, a couple new concepts we introduced here, so we'll take it step by step. Hopefully you'll understand it at the end. First, what we're doing is we're creating a class function. We're using that class keyword. We're not calling this function yet, but when we do call this function, we'd say something like factory.create slots. And this would look very different than the normal way we do it, which is we create an instance. We'd say like, var my factory is equal to factory. And then we could say something like, my factory dot create slots if this was an instance function. So this class function will help you when you see functions in the future. When you see a class name and then dot and then some sort of function create slots, you know that this is a class function. So that's how we would call this function. And this function returns one value. And this value is going to be an array of arrays. So real quick again, I'll just add a comment here, and hopefully I'll be able to help you visualize this. Right now we're saying we have an array, and this array has many arrays inside of it. So we're going to be adding 3 arrays, so we'll just practice by adding 3 arrays. And this array can have 3 elements, right? So it's an array. These items are separated by commas. And we could add an array of strings. So if we put string in here, for example, right, we would be able to say like A, comma, B. Our second one could be like C, comma, D, comma, E. Maybe we'd have F in our last one. And this would be an array of arrays, right? We have an outer array here, and it has 3 elements inside of it. So this would be the first array in my array. It would have 2 elements, A and B. This would be the second element, or the array at index 1. And we could say something like var, array of arrays is equal to this. And then we could say like, array of arrays. And we'd say like, index 0. And this would actually be equal to, right, A, comma, B. So if we wanted to, we could say something like, var first array is equal to array of arrays, and the real value of first array would be this element A, comma, B. Now in our case, what we're doing is we're basically creating 3 arrays, and each element has a slot. So this would be slot instance 1. And we could just, write slot in here. Actually, it's probably easier to visualize. Slot, 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 and finally a slot. Now, in each case, we have 3 elements, so we should add 3 elements into all of these items. And to think about it, we could do like slot 1, slot 2, slot 3, slot 4, slot 5, slot 6, slot 7, slot 8, slot 9. And hopefully this will help you think about, okay, actually let's just go back and refactor this. We're going to put this back to slot. That all we're really doing here is we're returning an array of arrays, and at each element that we're adding to our array of arrays is an array with slots in it. And we're getting our slot struct, or creating slot struct instances inside of for loops here. So let's take a look at this code. We next create 2 constants here, and we're going to use those in our for loops. Just kind of nice. We could just define these as 3, that's fine, but I like to write them as constants. And then we create a variable, and it's going to be named slots, and we're just initializing an empty array here. And we're going to be appending slot arrays to this slots array variable that we're creating here. So we're going to run our first for loop here, and when this first for loop runs, right, once, this for loop will run 3 times. So we're going to be adding 3 elements, right, slot 1, slot 2, and slot 3 inside of this for loop to a single array, and then we'll add this entire array to the slots array. Right, so we could just call this like slots. So how does that work? Well, we run to our for loop here, and we're saying start at 0, run to 3, like up to 3, not including 3, and create an empty array named slot array, and it's going to hold slot instances inside of it. Create the empty array, and then we're going to run another for loop, And we're going to run this 3 times. And each time we run through this for loop, we're going to create a slot instance. And we can just use our default initializer here. And each time we run through this for loop, we'll add that slot to the slot array. So we'll say slot array.append slot. And that will add each of the slots to the array. Then once the array is complete, the slot array, we'll add that to the slots. And since we're going to run this for loop 3 times, we're going to have 3 different arrays that each have 3 slots in it. So this is going to be 9 slots, which is going to be perfect because we have 9 different image views inside of our second container. So I'm going to remove this comment. Hopefully this helped you. Hopefully it wasn't confusing, and hopefully it helped you visualize what we're doing here. Understanding the idea of arrays inside of arrays might seem trivial, but it's actually really important because having embedded data structures is really common in computer science. So we're just having an array of arrays, but you could have array of tuples with arrays inside of there. You could have dictionaries with arrays with tuple. I mean the way in which you could mix data structures inside of Swift or any computer programming language can be very complex. So we're starting off with array of arrays. We're going to add an additional class function here, and this is going to be in order to create our slots so that we're not just creating a slot instance here. So let's use that class keyword again. So we're going to say class func create slot, and we'll pass in a parameter here called current cards, and this will be an array of slots, and this is going to return a slot instance to us. Now, why are we going to pass in an array of cards? Specifically, we're going to be passing the slot array. Well, we don't want to re-add the same card to a specific column more than once, right? We want to have 3 different cards in a column. So we're going to be using a randomizer in order to randomize the cards. But if the card already exists inside of this slot array, the slot array, we'll find a new card and we'll add that instead. So the first thing we're going to want to do here is we're going to want to create a variable, and its name is going to be current card values, and we'll make this an integer, and we'll set this equal to an empty array. All right. So we're going to create an array that's going to have the values that we've currently added. So we're going to use a for loop here, and we can say for slot in current cards, which is going to be our parameter here. We're going to say current card values dot append, and we're going to say slot dot value. So what are we doing here? Well, we're creating an empty array, and we're saying this array is going to have integers. So to fill up this array, we're going to iterate through the current cards parameter that we're going to pass in, and we know that current cards has a bunch of slots instances added to it. And so we're going to go through each one of those slot instances, and then we're going to find the value of the slot, and that will be an integer value, and we're going to add that to the current card values array. So with this in hand, we're going to create a random number next. So we're going to say var random number, and we can say this is going to be an integer, and we'll say arc for random underscore uniform, and this accepts an unsigned integer 32-bit. So we'll say UI int 32, and we'll pass in 13, and we need one more parenthesis there, and this will give us a random number between 0 and 13. So what this will allow us to do is it'll allow us to go 0 through king, and then we'll also be able to have a default. We're going to be using a switch case in just a minute here for a random number. But we want to do a little bit of logic here to make sure that our random number that we're generating here isn't already included inside of the current card values array. So we're going to say well contains, and we're going to pass in current card values, and the predicate here will be random number. We're going to say random number is equal to, and we can just copy this bit of code here. So we're going to use a while loop here, and this while loop is going to have an argument, and the argument here is contains. Now, contains is pretty cool. It's a way we can scan an array, and specifically we're going to be scanning for numbers. So we're going to say, well, the array, current card values, right, is our first parameter. So while this array contains the random number, keep running through this for loop. So if, we add 13 as our random number here, but 13 already exists in the current card values, it'll keep adding or generating new random numbers until it finds a new one. So once it finds a new one, then we are sure that the random number we're going to be using is not already added to our current card values array. Next, we'll create a variable, and this will be named slot. And we're going to assign it a value later on. For right now, we just want to create the variable, and then we'll write a switch statement, and we're going to switch on the random number, and case 0 will generate a slot. We're going to say this slot is going to be equal to, the value will be 1, and the image will be UI image, named, and this will be ace, and is red will be true. Well, how did I figure that out? If you just take a look at your XC images, right, the ace is red, so that is true, and the value will be 1, right? We're going to say ace is low. Maybe sometimes you play poker and ace is high, but in our case, ace is going to be low. You can switch this around if you'd like, but for my demo, I'm going to make ace low. For case 1, we're going to say slot is equal to slot, and the value will be 2. The image will be UI image, and it'll be named 2, and is red will be true. And let me just add some more spaces here so we can center this up. We're going to have to do all 13 cases, so bear with me here. We're going to do case 2, and be slot is equal to slot, and we'll do value, and the value will be 3, it'll be UI image, named, and this will be 3, and is red will be true. Case 3, slot is equal to slot, and the value will be 4, the image will be UI image, named, and it'll be 4, and is red will be true. And then we're on to case 4, and we're going to say slot is equal to slot, and the value will be 5 this time. We'll say UI image, named, and this will be 5. Is red will be false. And then we're going to say case 5, slot is equal to slot, and the value this time will be 6, and the image will be UI image, named, and this will be 6, and is red will be false. And then we have case 6. We'll say slot is equal to slot, and we'll say the value is going to be 7. The image will be UI image, not image view, named, and it'll be 7. And the is red will be true. Case 7, slot is equal to slot, and the value will be 8, and the image will be UI image, and it'll be named 8, and the is red will be equal to false. And then we can do case 8, and this will be slot is equal to slot, and the value will be 9, and the image will be named UI image, named, and we'll say 9, and the is red will be false. And then we'll do case 9, we'll say slot is equal to slot, value will be 10, and the image will be UI image, named, and this will be 10, and is red for 10 is true. And then we have case 10, and this will be slot is equal to slot, value will be 11, UI image, and this will be named, and this will be Jack, almost there, and isRed will be false. Case 11, slot is equal to slot,
and then we want to fill out the
value here. The slot value will be 12, and the image will be UI image named. This will be queen, and isRed will be false. And then we'll do case 12. This will be the last case we have to do, except for our default case. And we'll say slot is equal to slot. And then we'll do the value, and the value will be 13, and the image will be UI image. And we'll say named, and this will be king. And isRed will be true. We finally need a default case because we're using a switch statement, so we'll say default, and we'll say slot is equal to slot, and we'll just use the ace as our default, so we'll say UI image named, we'll say ace, and isRed will be equal to true, and then finally we can add our curly brace here. And finally, what we want to do is we want to return our slot from this function, and we can review what we've done here. Let's just clean this up a little bit. The first thing we did was we created a container called current card values, and we made this an array, and we said it was going to hold integers. And we know that our function named createSlot, which is a class function here, it gets passed in a parameter of the current cards, which is an array of slots. We also know that we need to return a slot instance, so we want to make sure that the slot instance that we're returning doesn't already exist in the column of the slot machine. So we're going to say for slot in current cards, we're going to grab the value from our current cards and we're going to append them to the current card values array. So we're going to append slot.value. And with that information, we're going to be able to check to make sure that when we generate a random number, that random number doesn't already exist in the current card values array. So we have a while loop here, and our while loop uses the contains keyword, and it checks our current card values array against the random number we've just generated. If the random number exists in the current card values array, then we generate a new random number. So with this random number that we're sure is unique, we next create a slot. So we don't instantiate it yet, we just create a variable named slot that's an instance of slot. And we assign the instance or value here inside of our switch statement. And based upon our random number, we have all of our different cases here. And for each of our case, we assign the value of the slot, the image, so if it's ace, its value is 1, and we also determine whether or not it's red, and this will make it really easy for us to check whether or not we have the same color in a row. Finally, we return the slot from this function that we generated using our random number. One other quick thing, I have an extraneous curly brace in here. We've added so many, I've managed to add an extra one. There's a really quick way I can re-indent everything. I can do Command A, which highlights everything, and hold down the Control key and press I, and this will re-indent, and it becomes very obvious that I have an extra curly brace at the end of my project here. So if you've been following along and copying exactly, just make sure you remove that extra curly brace, and your code should look something like this. So we now have our code working properly in order to create a slot. Now we want to upgrade our function createSlots to use our createSlot function. So what we're going to do here is we're going to remove the line of code here where we just created an empty or basic slot here, and we're instead going to use our factory function, specifically our class function here. So remember that in order to use our class function, we'll first create a variable named slot. We'll say factory, right? Because this is a class function, we call the function createSlot on the factory. So we say factory.createSlot, and then what we can do is we can pass in our slot array, right? And why do we have to pass in our slot array? Well, we want to make sure that we're not creating redundant slots inside of our slot array, so we pass that in each time so we can run our while loop here. And then we return the slot we get back from this function. So this is how we're going to call our class function. It's a little bit different than using that self keyword we had used when we call functions. Because it's a class function, we always use the class name and then we just call the function name on it. Next, we need to go back to our viewcontroller.swift file, and we're going to want to implement the class function we created in our factory. So we want to hold our slots in a property that we're going to be able to access in all of our functions, so that once we create our slots, we'll be able to access them everywhere. Let's go ahead and add an additional comment here. We can call this slots array, and this is going to be a variable, and it's going to be an array, so we'll call this slots, and it's going to hold slot instances. Now, actually, we need to add an additional bracket here, and we'll set this equal to an empty set of brackets. So what we're saying here is that our slots array is going to be an array of arrays, right? We actually generated one of those in our factory, so that we're going to return an array of arrays here, right? So we're going to set that create slots equal to our variable slots here, and we're going to initialize this as just being an empty array to get started. So we're going to say that this slots array is going to have 3 different arrays inside of it, and each one of those arrays is going to have 3 slots. So where should we create our slots? Well, we're only going to generate our slots when the user actually spins, when they're actually ready to play our game, and when they've already put some credits on the line, right? They shouldn't see any of these slots appear until they've actually put a bet on the line. So we're going to go into the spin button pressed function, and we'll say slots is equal to factory dot create slots, and this will generate a new set of slots every time we press the spin button, which makes sense, right? We want to update our slots and make them brand new each time we spin or play our game. While we're here, we're also going to want to go ahead and call our function setup second container. So we can say setup second container, and we'll pass in self.secondContainer. And the reason we're going to call this function is each time we update our slots, we're going to have to update our function setup second container. So we're just going to call that right now. And what we'll do is we'll actually display the slot image on our image views, and we're setting up our image views inside of the second container. So it makes sense to call setup second container inside of the spin button pressed function. So let's use our slots array to actually populate our second container image views. So we're going to go into the setup second container function. We're going to make some adjustments here. The first thing we want to do is we want to get the relevant slot for the particular image view. Remember that we're generating 9 image views, and it's getting generated from the 9 times that this for loop is occurring, right? So this top for loop is getting called 3 times, and each time that gets called, this for loop gets called 3 times, or evaluates 3 times. So 3 times 3 is 9. So we have 9 slots. We need to get one particular slot from our slots array. Well, in order to do that, let's create a variable, and we'll say the variable name is going to be slot, and it's going to be of type slot. So we also want to go ahead and let's add some spaces here, and we're going to say if slots dot count does not equal 0, we're going to say let slot container equal slots container number, and then we'll say slot is equal to slot container slot number, and then we can finally update the image view. So we're going to say slot image view dot image is equal to slot dot image, and we'll add an else statement below this. And we'll say else slot image view dot image is equal to UI image, and we'll say named, and we'll say ace. So what are we doing here? Well, we can actually even remove this background color. We don't need this line of code here. So we're going to first confirm that the slots array has a count, right? That there are actually slot items inside of our slots array, and there will be cases when there are no slots in our slot array. So when our application first loads up, we only call the create slots function from our factory when we press the spin button. We're not automatically pressing the spin button when our application loads up. So our else statement will trigger when our application first loads up. And what that will mean will be that we'll have 9 image views with just the ace, which would be kind of cool, right? Like just full aces on our screen. And then when we press the spin button, we'll actually be able to generate slots dynamically and randomly and fill them in appropriately. So what are we doing here? Well, we're first confirming that the slots array has a count. If it does not equal 0, we can say that, okay, we want to access one of the arrays inside of our slots array. Which array do we want to access? Well, we're going to say let slot container, which is an array, equals slots, and then we're going to index into it using the container number, right, which is our outer for loop here. And then we'll figure out, okay, now that we have an array of slots, we want to index into that and get a specific slot back. So we'll say slot container, and then we'll use our inner for loop here. And this way, we're going to be able to index from 0 through 9. And as we get our slots back, we'll update the image view property, the slot image view image property with our slots image. Otherwise, we'll just use the ace. So let's go ahead and run our application here. I'm going to switch this over to the 5S so it fits on my screen a little bit better. And I'm going to go ahead and run my application here. Once this application loads up, you're going to see that you have aces across the board. Now let's press the spin button, and we see that we now have all new image views here with our slots set up dynamically. Each time we set it, we're generating new slots. Right now we have a little bit of a bug that we need to solve, and that's when we press the spin button, we're generating new image views and we're actually stacking them on top. And this isn't good because we just are generating 9 new image views that are being held in memory each time we press the spin button. We want to first remove the old image views before we add new ones on top. So we're going to scroll to the bottom of our class here, our view controller class, and we'll create a section called helpers. And the helper function that we're first going to implement is going to be remove, we need the func keyword, func, remove slot image views. And this isn't going to take any parameters or return anything. And the first thing we're going to do here is we're going to say if self.secondContainer does not equal nil. And what we're going to basically be confirming here is, okay, have we set up the second container? Because we don't want to try to remove image views from a container that doesn't exist, right? We're going to be trying to access second container here, and if it doesn't exist and we try to do some logic on it, it could potentially break our project. So we're just going to add this if statement in here to make sure that, if we were to change our project around, always great to have this safeguard in there. We next want to figure out which container we're going to be looking at. So we're going to say let container, and let's say this is going to be UI view equal self.secondContainer. And we have to make this an optional, and we're going to unwrap the second container, right? Because there's a chance, again, right, that second container doesn't exist. Even though we're testing for nilness here, we still want to make sure that we're unwrapping this. Because we've tested for nilness, it's fine to explicitly unwrap the second container. But because this is a property, right, there's always this chance that second container wasn't set up. So we test for nilness, and then we unwrap the optional here. And then what we can do here is we can say let subviews array equal container dot subviews, and then we'll say for view in subviews, and then we're going to add curly braces. We'll say view dot remove from superview. And actually, so this exclamation point needs to be next to subviews. And let's just remove these additional returns. We don't need those. And let's talk about what we have done here. Well, we check to make sure the second container exists. If it does, we unwrap it. And we're saying for subviews, which is going to be an array here. And it's an optional because there might not be any subviews in our container. And if that's the case, then this would be nil. Subviews would be nil. But if there are some subviews in our container, go ahead and create an array of all of the subviews. So if we've added image views to the second container, right, we can say that there will be an array of all those image views. And then what we can do is we can say for view in subviews, and notice that we have to unwrap subviews, right, because there's a chance that subviews is nil, right? So we're saying for view in subviews. We're going to say view.remove from superview. And the view here is going to be our image view, and we're basically saying, okay, remove that. And we're running a for loop here on our subviews array so we can iterate through all the image views that we're adding to our second container. So this is how we can go through and remove all the image views from our second container. We finally want to call this function in the spin button pressed function. And we're going to do that at the very top here. This should be the first line of code we have in this function. So we're going to say remove slot image views. So the next thing we want to do is we want to add another function, and this function will also be a helper function. And the purpose of this function is going to be to reset our game, right? We're going to implement the reset game functionality. We can just press reset. So we're going to say func hard reset, and we're going to add some curly braces here. And the first thing we want to do is we want to remove all image views, right? We want to start with all our aces on the screen. So we're going to say remove slot image views. The second thing we want to do is we want to clear out the slots array. And even though when we respin, right, we can regenerate or reset up the slots and, you know, update the property of slots, it's nice to just clear everything out of the slots array. So the way we do that is we're going to say slots.remove all and keep capacity. Yeah, let's keep the capacity because we're always going to be adding 9 slots to the slots array. We might as well keep the capacity of our slots array or the amount of memory we're going to need for the slots when we generate it, because we can be pretty sure that even when the user presses reset, they're probably going to want to play our game again because it's so awesome. Then what we can do is we can say self.setup second container, and we're going to say self.second container. And this is basically going to reset the aces and it's going to regenerate our image views for us. And we also want to start setting up our credits and our winning. Now, we're not going to fully implement that in this video, but we do want to add 2 properties. So we can add that right below our slots array here. And we first want to add a comment here. We can call this stats. And we're going to need 3 properties here. We're only going to be using 2, but we'll generate all 3 right now. So we'll say credits, and we'll make this an integer, and we'll set its initial value to 0, right? How many credits does the user have? We'll say var current bet, and we'll just make this an integer as well. We can also set this equal to 0. And then we'll say var winnings, and we'll make this an integer, and we'll set its initial value to 0. So the 2 we're going to be looking at in this video are going to be credits and winnings. So when we have a hard reset, we're going to reset the credits for our user to be 50, and we're going to reset the winnings to be 0, right? We're going to say the user, when they want to reset the game, hasn't won anything yet, but we're going to start them off with 50 credits. And finally, I didn't think we'd have a chance to introduce this in this video, but we might as well update the current bet and set this equal to 0. Now, the current bet is just going to be, has the user bet 1? Has the user bet 5 yet? How much are they betting on this spin? And we can just reset this to 0 as part of our hard reset. Now, we want to actually call this function, and we'll do that in the viewDidLoad function, right? That probably makes sense to you because when we first load up our application, we want to start off with a reset game. We don't want our game to preserve any state. So we're going to say hard reset at the very bottom of our viewDidLoad function. Now, maybe you can guess which bit of code we want to remove in viewDidLoad. There's a bit of redundancy right now, and that's in hard reset. We're calling the function setup second container, so we don't want to call it twice. So we can just remove this line of code here, and we'll let hard reset set up our second container. There's a second place we want to call the function hard reset, and that's going to be in the reset button pressed function. So we can add hard reset here. And you see, by adding this functionality into its own function, it's really easy for us to reset the state of our game from multiple places without having to rewrite a bunch of code. So our reset button press is going to kind of work like our initial setup. However, we're not going to need to set up our first, third, and fourth container because they're already going to be set up from the first time our application loads up. Now we want to add an additional function. So let's scroll to the bottom here. And below hard reset, we're going to add a function to update our credits label, our bet label, and our winner paid label. So we're going to call this function update main view. And this function is going to first update our credits label. So we can actually use the self keyword. It will work either way, but when accessing UI elements, I tend to like to use the self keyword. It's just a habit of mine. You can access it either way. It'll work the same way. But we can say self.creditslabel.text is equal to credits. And this is just going to use our instance variables or properties that we set up in order to keep track of how many credits we should display on the screen. And every time we call update main view, we'll update the text to match what our properties value is. So we also want to update bet label, so we can say self.betlabel.text, and we'll set this equal to current bet. And then we want to update our winner paid label, so we'll say winner paid label.text. Oh, I'm going to use the self keyword, so let me just fix that. Self.winnerpaidlabel.text is equal to, and we'll insert winnings. So as we update each one of these properties, if the user bets more, if the user gains or loses credits, if the user gets winnings, we'll just be able to call this function update main view and very quickly be able to update all of our labels. In fact, let's call this right out of the gate after our hard reset, after we set up some initial values for credits, set the winnings to 0 and the current bet to 0, and we'll just immediately call update main view. And every time we do a hard reset, either from first loading up our application or pressing the reset button, we're going to update our main view to reflect the changes in the credits, winnings, and current bet. The next thing we want to do is we want to create a helper function to create alert views, so we don't have to keep coding out the UI alert controller code over and over again. We're going to be able to just pass in a header and a message, and we'll immediately be able to just generate the information to display inside of our alert controller. So we're going to write in func show alert with text, and the first parameter will be named header, and it'll be a string, and we'll give it a default value. So the default value basically means that if we don't pass in a header, it'll automatically default to warning. So the header is now optional. However, we're not going to specify a default value for our message here, which will be our second parameter. So it'll be required to pass in a message, which will be a string, when we call the function show alert with text. So we're actually just going to go ahead and create a alert here. And this is going to be an instance of UI alert controller. And when we initialize this, we're going to initialize it with a title, so we can just use our header. And the message will be just the message parameter we're going to pass in. And we're going to just use the default style here, so we can say UI alert controller dot style dot alert. And this will just be the default style we use for our alert controller here. What we do need to do is we need to add an action. So we're going to say alert dot add action, and we need to pass in a UI alert action here. So we can say UI alert action, and we need a title. So we'll put OK. And the style will be UI alert action style dot default. And the handler will be nil. We don't need a handler here. And finally, we're just going to present this on the screen. So we'll say self.present view controller, and we'll pass in our alert and we'll animate it, and the completion will be nil. Okay, let's talk about what we're doing inside this function. We're going to be able to call this function show alert with text throughout our application here if we're doing something that's invalid. For example, if the user doesn't have enough credits, if they're trying to bet more than the max bet that we're going to allow, which is going to be 5, we're going to pop up an alert. And alerts occur, I'm sure you've seen before in the different applications you've used. And they have a header and they have a message, right? It's like warning, or error or something along those lines. And then there's a message and it gives you a little bit more information about what's going wrong. And that's what we're just filling out here when we say UI alert controller. We're filling out a default header, a message, and then we're just going to use our default style here. What's a little bit different in iOS 8, we have to actually add an action here. So we explicitly add an action. And this is going to allow us to dismiss the alert controller. So by pressing OK, we're going to be able to get rid of this. And then we actually need to display this alert controller on the screen. So we're going to say self present view controller, and we're going to display our alert on the screen. We're going to animate it, and we don't need a completion block. There's no code that we need to run after the alert controller is presented on the screen. So this is just, again, modularizing our code, making it really quick to show alerts on the screen. That's why we're doing this. So we now want to implement the bet1 button pressed function. Specifically, we're going to be updating the ability for the user to bet. So the first thing we're going to do is we're going to add an if statement, and we want to confirm that the user actually has credits to bet. If they're out of credits, we don't want them to be allowed to bet or play our game. So we're going to say if credits is less than or equal to 0, we're going to use that handy function we created in our last video, which is going to be to show an alert with text. And the header here can be no more credits. And the message will be reset game. And this is just a friendly reminder to our user, right, that they're out of credits and that they actually need to reset in order to get more credits. And then we can add an else statement here below this. We'll say else, and we're going to embed an if statement inside of this, and we'll say if current bet is less than 5, and we'll say current bet plus equals 1, and then we'll say credits minus equals 1. And then at the end here, we'll call update main view. Now we could add another else statement below here. We could say show alert with text, and we can actually remove the header completely here. We'll just pass in a message, and the message would be you can only bet 5 credits at a time. And notice here that we're not passing in a header because we have a default value for our header, so we're not required to pass in a header here. But we are telling our user, okay, you can only bet 5 credits at a time, and that's why we're checking to make sure the current bet is less than 5 credits. So if the current bet is less than 5 credits, we're going to go ahead and add 1 credit to the bet, and we're going to remove 1 credit from our current pool of credits. And once we make this change, we can actually move update main view right below the credits here. We'll say, okay, if you are in fact allowed to make changes, right, and we're going to update the current bet and the amount of credits, okay, update that and show that on the labels. So we're just going to call the function update main view. Let's go ahead and run our application, see if this actually works. We can hit the run button. We haven't run in a little bit. So we can bet 1, and we see that we now have 49. The bet is 1. And if we try to go to 5, we get a warning here, and it tells us that we can only bet 5 credits at a time. And notice it used the default header, which was warning, that we set up in our last video. Now let's implement the bet max button pressed function. And once again, we're going to test to make sure the credits is less than 5. So we're going to say if credits is less than or equal to 5, we're going to show alert with text, and we're going to say not enough credits, and the message would be bet less, right? So hopefully the user will get the idea that they need to go and bet 1 instead of trying to bet 5. But the reason we have a bet max button pressed function is it'll be easier for the user to bet more than just one at a time if they want. We're going to add an else statement below, which means that the user does have enough credits. So let's first add an if statement. We'll say if current bet is less than 5, which means the user hasn't already bet the max amount yet. We'll say that the credits that we want the user to have is going to be minus equal 5 minus the current bet. Why are we doing this? Well, if the user's already bet 4, we don't want to subtract 5, right? We only want to subtract 1. But if the user hasn't bet anything yet, we want to remove 5. So it'll be 5 minus the current bet, the amount of credits the user should have. And then the current bet, we'll just set this equal to 5. We also then want to update our main view, so we can call the function update main view to update the labels. Then we can add an else statement below, and we can say else, and we'll show an alert with text. We don't need a header, and the message will be you can only bet 5 credits at a time. So basically the same thing as our last error message we had up here. And let's try running our application now and make sure this new bit of code works. So let's try betting the max here. We are able to bet the max, and we see that we get a warning if we try to bet the max again. Now just to make sure it's deducting the right amount of credits, let's add 1 and then try betting the max, and we see that it's going to 45 and our bet is now 5. We now want to create a helper class called slotBrain, which is going to be responsible for computing the winnings based upon the slots and how they're arranged inside of our view. So we're going to go to File, New File. We can choose iOS source Swift file, press Next, and we can call this slotBrain and press Create. And the first thing we're going to do is we're going to want to use our class keyword here. We're going to call this slotBrain. Let's add some curly braces. And we're going to create a function. This is going to be a class function. So we'll use that func keyword, and it's going to be unpack slots into slot rows. And it's going to have a parameter here. We're going to pass in slots. So we're going to pass in our array of arrays, which is going to have slots. And it's going to return a value, and it's going to return an array of rearranged slots. And we can add our curly braces here. So the responsibility of this function is going to be to take our our slots array that we have in the view controller, and rearrange them so that they're not arranged in columns, but they're arranged in rows. So this will give us a chance to really play with this array, understand how we can index into embedded arrays, make sure we understand that completely. And it'll also be a little bit more realistic, right? We want to look at rows, even though we're populating things in terms of columns. So we're going to create 3 variables. The first variable we're going to say is going to be slot row. And this is going to be an array that's going to have slots in it. And we'll make this an empty array. And we can say var slot row 2. And this is also going to hold slots. And this will be an empty array. And we'll say var slot row 3. And this will also hold slots. And this will also be an empty array. And then what we're going to do is we're going to use a for loop. So we're going to say for slot array in slots, right? For the arrays inside of this parameter that we're passing in slot. Excuse me, let's pluralize now. Let's make that slots. We want to index into the slots array and get back the arrays. So we're going to use our fast enumeration here. And then what we're going to be able to do is we're going to say for var index equals 0, index is less than slot array dot count, and we can say index plus plus, and this will allow us to index into the slot array. So we're going to say let slot equals slot array, and we'll use the index parameter here to get back the slot inside of our slot array. And then we'll use an if statement here. We're going to say if index equals 0, slot row dot append, and we're going to append our slot. And then we can say else if index equals 1, we'll say slot row 2 dot append, and we'll append our slot, and that should be lowercase. And finally, we'll say else if index equals 2, we'll say slot row 3 dot append, and we'll append our slot. And finally, we can just add an else statement here. We don't really need this, but we'll say print line, and we can add like error. So if we see this, we know we've done something wrong, right? Maybe we've added too many elements into our slot array here. We added 4 slots for some silly reason. Just done something wrong, right? We should never see this print line come out to our console. So basically what we're doing here is we're running through our for loop here, and we're first getting out all of the arrays inside of our slots array. And then once we have that, we're getting all the slots out of each slot array, right? So we're going to essentially be getting 9 different slots out. And then we're just saying if the index is equal to 0, okay, well that means we're accessing an element at index 0, which means that it's in the first row. So we want to add it to the slot row. Likewise, if we access index 1, that means it's in the second row, so we're going to add it to slot row 2. And the same thing for slot row 3 here, slot row 3, where we append our slot. So now that we've added each of these elements into the proper slot row, we can now re-add all of our slot rows into a variable. So we're going to say var slot in rows, and we can say this is going to be an array. It's going to hold arrays that have slots in them. And we can say this is going to be equal to slot row, comma, slot row 2, comma, slot row 3. And I see that I have a little typo here. I was using autocomplete, so I didn't even catch this. We're going to use slot row, not slow row. It's a silly mistake. I want to be careful when you type these things in. Even I make mistakes. And then finally, we want to return slot in rows. So what we're doing here is we're returning this reordered array of arrays, and now when we unpack this, they'll be in rows rather than being in columns. Now we're going to create another class function that's going to actually access the unpacked slots into rows. So we're going to say class func, and we're going to say compute winnings. And this is actually going to be the function that we call inside of the view controller file. And this is going to accept a parameter. It's going to be slots, and this will be an array that has slot instances inside of it. And it's going to return an integer, and this is just going to be the winning multiplier we're going to use, that we're going to multiply by the amount the user has bet. So the first thing we're going to do is we're going to go ahead and say var slots in rows, and we'll say this is going to be equal to unpack slots into rows, and we'll just pass in our slots parameter in that we're going to get when we call this function. And the next thing we want to do is we want to create a variable, and we'll say var winnings equals 0, and then we'll say var flush win count is equal to 0, and then we'll say var 3 of kind win count is equal to 0, and then we'll say var straight win count equals 0. And basically what we're going to do here is we're going to be checking, okay, how many times did they get a flush? And if they get 3 flushes, we'll give them an extra bonus, and the same will be for 3 of a kind, or if they get all 3 of the same number, or if they get a bunch of straights, right? If they get 3 straights, that's an incredible win. Statistically, it's very unlikely to occur, so we'll give them a super duper reward. So we're going to use a for loop here. We'll say for slot row in slots in rows, and we're just going to iterate over each slot row inside of slots and rows, and we'll be doing some checking. So we're going to have to, in the next few videos, write some functions here to check for flushes, to check for 3 of a kinds, and to check for 3 in a rows. For now, we can simply return winnings, and then in our next video, we can start checking for each one of these items. So we now want to write a function that's going to allow us to check for flushes. So I'm going to add a comment here. We're going to call this helpers. And this name of this function is going to be check flush, and it's going to be a class function. So we can say class func check flush, and it's going to take one parameter, and that's going to be a slot row, and that's going to be an array that's going to hold slot instances, and it's going to return a bool as to whether or not there is actually a flush. So let me just add a few returns here so we have a bit of space to work with. And the first thing we're going to do is we're going to create some constants here. We could say let slot1 equals slot row, and we'll index into it. We'll say index 0. We can say let slot2 equals slot row, index 1. We can say let slot3 equals slot row, index 2. And basically what we're doing here is we're just getting access to each one of the slots inside of the slot array. Instead of using a for loop, we're just indexing into these because we know we're always going to have 3 items inside of our slot row. Now, you could make this dynamic if you want to have more slot rows, that'd be fine. But for now, it's nice to practice accessing instances inside of our array directly using this syntax. So we're going to say if slot1 dot is red equals true, and slot2 dot end ampersand ampersand slot2 dot is red equals true, and slot3 dot is red equals true, return true. And then we could add an else if slot1 dot is red equals false, and slot2 dot is red equals false, and slot3 dot is red equals false. You can also return true. Finally, we can return false. So we're going to say else return false if this isn't the case. So I know that technically flushes are supposed to be same type, be it diamonds, hearts, but we're going to do it based on color here. This is going to be our version of the flush. If you want to do some refactoring, add some more images, that's awesome. But to make this a little bit more simple, we're just going to test based on color. So maybe check color would be a more apt name. So the first thing we're going to do is we're going to check to make sure if they're all red, we're going to return true. However, if they're not all red, right, if they're all equal to false, we're going to return true as well. So we can call this function inside of our for loop for slot row and slot rows. And we'll say if check flush, and we'll pass in our slot row. And we're going to say it's equal to true. Print line, and we'll say flush, and we'll say winnings plus equals 1, and we'll say flush count, flush win count plus equals 1. And basically what we're going to do here is going to say if we return true from this function check flush. Notice this is a class function. Last time we called a class function in our factory, we did factory.createSlot. But what we could have done is just directly access the function directly with check flush. We don't have to use the self keyword because it's not an instance function. It's a class function, so we can actually just use check flush. That's fine. We could have done that with the factory. I want to show you both ways that you could do that. So if this returns true, there is a flush. We're going to add 1 to the winnings multiplier. Flushes are pretty common, so we're going to go ahead and just add 1. And we're going to add 1 to the flush win count. Now, we want to check if the flush win count is equal to 3, we're going to call that a royal flush. Again, I know it's not technically a royal flush, but that's the name we're going to use for it. So we're going to say if flush win count equals 3, print line, and we'll say royal flush. And this is just for us. We'll get to see, print out to our console. It'll be really easy to see when there's winnings. And we'll say winnings plus equals 15. And this will give the user an added bonus to their winnings multiplier if they get a royal flush. Now we're going to be adding a function to check for 3 in a row, so we can make this a class function as well. We're going to say class func check 3 in a row. We're going to say slot row slot, and we'll make this a bool. And once again, we can even just copy this code here for our slots. So we can say slot 1 is going to be the instance at index 0 for our slot row. Slot 2 is going to be the instance at index 1 in our slot row, and slot 3 is going to be the instance at index 2 in our slot row. And then we can run an if statement here. We could say if slot1.value is equal to slot2.value minus 1, and slot1.value is equal to slot3.value minus 2, we're going to return true. Otherwise, we'll return false. So what are we doing here? Well, we're saying if the first value is equal to the second value minus 1, so if we have 3, and the next value is 4, right? 4 minus 1 is 3, so they'd be equal. And then we'd say, okay, if the slot value 1 is equal to 3, and slot 3 is equal to 5, 5 minus 2 is 3, so these are also the same value. That means we have a run, right? 3, 4, 5, and that's 3 in a row. We also want to add an additional else if here. And this one will test if it's going the opposite way. So we're going to say slot1.value is equal to slot2.value plus 1, and slot1.value is equal to slot3.value plus 2. And this will return true as well. So this is just going the opposite way. And I need one additional equal sign there because we want to do a comparison. We don't want to assign a value. So if neither one of these are true, we're going to return false. And now we can call this function inside of our for loop here in the compute winnings. So we can say if check 3 in a row, and we'll pass in our slot row. And then we'll add some curly braces here. We can print line 3 in a row. And we can say winnings plus equals 1. And then we can do straight win count plus equals 1. And then we can do a test here. We can say if straight win count equals 3, we'll do print line. And we'll say epic straight, and we can also update our winnings, and this is much more difficult, so let's say winnings plus equals 1000. The last thing we want to check for is 3 of a kind, and this is going to be very similar to our 2 previous functions, so hopefully it'll seem pretty straightforward to you. We're going to create another class function, and this is going to be check 3 of a kind. And once again, we're going to pass in a slot row here. And it'll be an array of slot instances. And it's going to return a bool. And we can just copy and paste these 3 slots. We're going to access the slots the same way. And then we can do some sort of test on it. So we're going to say if slot1.value equals slot2.value and slot1.value equals slot3.value, will return true. Otherwise, we'll return false. Now we can call this function inside of our for loop, inside of the compute winnings function. And we'll say if check 3 of a kind, we'll pass in our slot row here. We'll say print line 3 of a kind. And then we can say winnings plus equals 3. And then we can say 3 of a kind win count plus equals 1. And we're going to give them a little bit more for 3 of a kind here. That's fine. You can go back and play with these winnings and give them different numbers. You know, maybe you're going to rig it for yourself. Maybe you're going to make it super easy for the user to gain lots of credits in your game. Really depends on what you want to do. But what we will do down here is we'll say if 3 of a kind win count equals 3. We'll print line, we could say something like 3s all around. And then we can say winnings plus equals, and let's just give them 50. We already gave them 1,000 for the epic straight. Just one thing I want to point out before we finish this video, and that's when we're adding to the winnings, we're doing plus equals. So if the user gets like a flush win count is equal to 3, right? They get the royal flush here. They're going to get 3 points for the winnings here when we check for the flush, and then they're going to get an additional 15. So they're actually going to get a multiplier of 18. So this is going to stack. If you want to do a little differently, you would just reassign the value. You'd say winnings equals the value. But I like to stack it. So if they get 2 flushes, right, they're going to get a winnings multiplier of 2. It's finally time to implement our slot brain that we've spent so much time working on into our project. Specifically, when we press the spin button, we're going to check our slots and see what the winning multiplier should be. So right after we set up our second container, we're going to add some bit of code here. And we're going to say var winning multiplier. We're going to set this equal to slot brain dot compute winnings. And we're going to pass in our slots. And remember, this is going to be generated by a factory dot create slots here. And then what we can do is we can say our winnings is going to be equal to the winning multiplier times the current bet, right? So if the user bets 4 and the winning multiplier is 2, they'll get 8 winnings back. We also want to update the credits. So we'll say the credits is going to be equal plus equals the winnings. So we'll actually give them the winnings. And then we'll set the current bet back down to 0. So we'll set the current bet down to 0, and then we'll call the function update main view. And this will make our labels display the changes to our winnings, our credits, and our current bet. So let's go ahead and run our application and see, if we can get some flushes, if we can get some 3 in a rows. Hopefully luck will be on our side. And if not, we'll just keep spinning until we get some luck, because we can always reset. So now that our application is loaded up here, let's go ahead and bet 1. And we'll spin. It doesn't look like we got anything, so let's bet again and spin. Oh, we got a flush. We got 3 blacks here. Let's try betting again. We got another flush. We got 2 flushes actually. That's awesome. So the winner paid got up to 2 here. So let's bet again. We lost. Bet again. We got a flush, so we got 1 back. Bet again. We got 1, so we got another flush. So we can see we can play this game, and we're getting some flushes here. Let's try betting 5. Oh, we lost that one. And we lost that one too. So our game is working properly. If you're so inclined, you can make upgrades. Maybe you change the colors of things around. You can add additional cards to the assets. You can really kind of make this your own. But hopefully, as you've gone through this project, and you've spent quite a bit of time going through, we've really learned about subviews, creating code dynamically, and views dynamically. We've ran through for loops and for loops inside of for loops, arrays inside of arrays. And if you're struggling with this project a little bit, now that you're at the end, I would encourage you to go back and try this again. I think the second time around it's a lot easier. There are a lot of difficult concepts in here if this is your first programming language. And I think going through this material more than once can be really helpful, because we are doing so many things in code and there are so many new properties. So it's completely okay if this isn't making perfect sense yet. At the same token, feel free to move forward, because we have plenty more chances to practice this stuff in the future. And we're going to have a whole assignment upcoming where you're going to get to practice all of these things yourself. It's time to solve our first assignment. We're going to go ahead and open up Xcode, and we're going to create a new Xcode project. So we're going to go ahead to iOS application. We're going to choose single view application. And as soon as this finishes loading, we can go ahead and press next. And let's go ahead and call this lemonade stand. And I'm going to leave my organization name and my organization identifier the same. Now I'm going to switch this over to Swift. I was playing around in Objective-C earlier. So we want to make sure we're writing this in the Swift programming language, and we're going to choose iPhone for our device. And we can choose next. And we're going to go ahead and create this. We're going to put this right on our desktop here. and we can enlarge our project. So because we're going to be building this for the iPhone, again, we're not worrying too much about UI right now. We're really just trying to understand the fundamentals of computer programming. Like we've been doing in the past, we're going to go ahead and switch this over to compact width. And if you'd like to, you can also select your view controller, and you can adjust in the attributes inspector the size, for the iPhone 4-inch screen if you want. If you didn't try it out for the 3.5-inch screen, that's fine as well. And I'm going to go ahead and switch the orientation to portrait. So we can now start adding some UI elements to our scene here. And the first thing we're going to do is we're going to go ahead and add a label. And let's go ahead and just drag this into the upper left-hand corner here. And we're going to make this a label. We're going to say this is going to be you have. And we're going to use this to track the amount of money that we have currently. So we're going to go ahead and go to the attributes inspector here. And let's change the color to be red. And let's drag another label in here. And let's line these up nicely. And this is actually going to display the amount of money we have. So we can just put a default placeholder here. And let's change its color to green, just so there's a little bit of contrast here. We can go into our color wheel here, and we'll just select green. Cool. We'll also need two more labels here, and we're going to use these labels to track the number of lemons and ice cubes we have in our project. We're going to be buying ice cubes and lemons, and we're going to be able to make lemonade with that. So let's go ahead and just add some default text here. We can say 1 lemon, and we can say this is 1 ice cube. And we're also going to add another label here, and this is going to be the steps to make our lemonade here. So let's go ahead and we're going to say step 1, purchase supplies. And let's go ahead and add another label below this, and we'll say lemons for $2. And we're going to need 2 buttons here. So let's go ahead and search for our buttons, and let's drag them in. And the first button is going to be the ability to increment or increase the number of lemons we would like to purchase by 1. And the second one is going to be a minus sign, not an underscore here. And this will be the ability to lower the number of lemons we're going to be purchasing. So we need a label in between these two. And this label is going to display the number of items we have on the counter that we're getting ready to purchase. So let's go ahead and just put a placeholder. We'll put 10 for now. And drag this up. Let's line everything up a little bit nicer. Center that up and bring that a little bit to the right. So, you can play around with this UI and make it your own if you'd like. I'm just kind of dropping things in here. Let's go ahead and change the color of step 1 while we're here too, just to make it stand out a little bit. I'd like a blue, so let me go back to my color wheel here and we'll choose blue. And while we're at it, let's add a colon after lemon for $2, just so it's really obvious, that this is the number we're going to be changing. Let's just go ahead and copy all of this stuff, because we're going to be doing basically the same thing for ice cubes right below it. So what I did there is I just selected all my items and I pressed Command C and then Command V. That was the way I could paste. So that's a quick way you can go about doing that. So let's just go in here and we're going to change our text. We're going to say ice cubes for $1. We'll make the price a little bit different. And let's add a colon at the end there too. And we'll have our plus and our minus. Let's just add a different default value here, just so it stands out a little bit nicer for us as well. And we'll just make sure all this stuff is lined up appropriately. In fact, we can even bring these pluses in a little bit more and these minuses a tiny bit more as well. So we also are going to add step 2. So again, instead of just dragging this label, I want the color of the font to be the same. So it's a nice idea to just go ahead and copy and paste this. So again, with Command C and Command V, you can select View Objects here. And let's go ahead and change the text here. We're going to say step 2, mix your lemonade. And let's add another label down here. This one's going to be black. And we're actually going to make this text a little bit smaller just because you don't want it to stand out as much to the user. So let's go ahead and make this size 14 text. And I'm going to say, do your customers prefer more ice or lemons today? Now, we see that this is going off the screen. I could just drag this over, but I want this to be 2 lines. So the first thing we want to do is we want to change the number of lines to 0. So we'll let Xcode automatically figure it out for us. And then let's go ahead and stretch this down and shorten this up so we can kind of get this all into 2 lines here. And we'll kind of resize our label until everything fits nicely. And I'm going to align this to the right over here. So this is just a hint to our users, do they want more lemons today or is it ice? What is the perfect ratio in order to create the best lemonade? Well, we're going to be doing this plus and minus again to choose our recipe. So let's go ahead and we could just copy all this stuff here and paste it down here. And this will just be a quick way we can get the pluses and minuses just so we don't have to keep recreating these buttons over and over again. And this will be lemons. And we'll say this is going to be ice cubes. And I actually want to align this a little bit closer. So we're going to have the buttons be the guide here for this. And actually, let's do the same thing up here. So that way, the priority, in my opinion, visually, becomes these pluses and minuses so the users know that they can play around with the ratios. We need a final step here, and that's going to be step 3. And this step we're going to say start selling your brew. Or you could say start selling your lemonade. I think that this fits in very nicely. And we're going to need another note here. So let's go ahead and just copy and paste this in. Notice that it didn't keep this font nice here for us. So let's go ahead and just reset that to 13. And we can do at the end of the day, you will either make or lose money. And then we'll say if you don't have enough money to buy new inventory, then you lose the game. So we'll add a little bit of risk here. You could potentially lose. We see that this is resizing. And we finally need a button at the bottom here, which will give our user the ability to start the day. So let's go ahead and drop that at the bottom here. Let's add a background color for this. So we're going to set the background color. Let's use yellow since we're talking about lemonade. And that will stand out nicely in our project. And let's just enlarge this button a bit so it's really obvious that we can start the day here. So this is our UI setup. Feel free to change these colors. Again, we're not worrying heavily about graphics yet. We're going to be getting into that later in the course. Right now, it's really just learning the fundamentals of computer programming and solving this first assignment. Now that we have our storyboard set up, it's time to link up all of our view objects to our view controller. That way we'll be able to reference these view objects, change them. Specifically, we're going to be changing our money supply, the number of lemons we have, and so on and so forth. So the first thing we want to actually hook up here is going to be our money supply. So let's hold down the Alt key and press on viewcontroller.swift. And this should bring up our assistant editor here. And this will allow us to link everything up appropriately. So the first thing we want to do is let's go ahead and select our money supply label here. And we can hold down the control key and drag into our view controller file here. And we're going to call this money supply count. And we can go ahead and press connect. We can leave the type as UI label and the storage type as weak. We've been doing this a few times, so hopefully that seems consistent to you. Next, we're going to hook up our lemon supply count label. And to do that, we're going to make sure we have our one lemon label selected in our storyboard. And we're going to hold down the control key and drag to our view controller. And we're going to make this an outlet connection again. This is going to be named lemon supply count. And again, the type is going to be UI label. The storage type can be weak. We'll talk about strong versus weak in the future, but we can just go ahead and connect that up. And we're going to do our one ice cube count as well. So we're going to do outlet, and we'll call this ice cube supply count. And again, we're going to leave the same default, so let's just go ahead and hook this up. Now, I like to group similar IB outlets together, so I'm going to go ahead and remove these default returns just to kind of bunch my code a little bit nicer. Since all these three labels are at the top here, our next set of labels for our purchase supply, we'll group those together as well. So personal preference, but that's what I'm going to do. Next, let's go ahead and set up our lemon purchase count. So again, let's control drag. Make sure you have the right view object selected. And let's call this lemon purchase count. And we're also going to do the same thing for our ice cube. So we'll call this ice cube purchase count. And again, I'm going to go ahead and just group these together to remove that additional return. Not required, but I like to organize my code this way. And finally, we need to connect up the labels for our lemons and our ice cubes for our mix count. So we're going to call this lemon mix count. And we'll do the same thing again, holding down the control key for our ice cube. So we're going to say ice cube mix count. So again, we'll go ahead and remove the additional return. Next, we need to hook up our buttons. We're going to make them IB actions. We're going to start with the purchase lemon IB action. So let's select the plus here, and we're going to control drag in. We're going to make this an action. And let's go ahead and call this purchase lemon button pressed. And we can make the sender any object. You can also switch this to UI button if you want to be explicit. We're not going to be using the parameter at all, so it doesn't really matter which one you choose. Touch up inside is fine for the event, and we'll choose arguments will be the sender here. So we can go ahead and connect that up. And that's our first IB action. Next, let's go ahead and set up the plus button here for our ice cubes. And this is going to be purchase ice cube button press. So we're going to go ahead and make this an action. And we can say purchase ice cube button pressed. And we're not going to be using the sender. So again, we can just leave all the defaults the same. Any object, touch up inside and sender. We can connect that up. We also want to go ahead and hook up our subtraction sign here. So we're going to call this unpurchased lemon button pressed. And let's make sure that we make this an action. We don't want to make that an outlet. We're also going to leave the type as any object, touch up inside and sender. We can connect that up. Let's go ahead and add a return here. Spacey is a little bit nicer. And let's hook up our subtraction sign button here for our unpurchased ice cube button pressed. And again, make sure to make this an action. Don't make this an outlet. And we'll make this type any object, touch up inside, that's fine. And we'll connect that up as well. So next we want to hook up the 4 buttons we have for our mix. So hopefully you can think what the naming convention will be, and it'll be consistent with what we've been doing before. Again, we'll make this an action. We'll say mix lemon button pressed. And we can connect that. And the next will be for the ice cube. So we can say, make this an action. Mix ice cube button pressed. And we'll connect that. Let's add a return. I like to add returns or spaces between my functions. And then we're also going to do the unpurchased mix, or excuse me, unmix lemon button pressed. And we can connect that. Oh, I made it an IB outlet. That's a mistake. So if you make that mistake, you can go ahead and just click in here. Don't forget to remove it from the connections inspector. And I'll just hook that up again really quickly here. So we'll go to action, unmix lemon button pressed. And we'll do the same for our ice cube here. So we'll say that this is going to be unmix ice cube button pressed. And we'll connect that up. We have one final button that we need to hook up, and that's our start day button. And we'll do that at the very bottom here. I'm going to go ahead and just add some returns here just so we can see this a little bit easier. And let's just add this action here. And we'll call this start day button pressed. And we can connect that up. So now we've been able to hook up all of our IB outlets and IB actions. And hopefully you were able to follow along in this video, and we're finally ready to get started writing a bit of code in order to get our application to work. Now we need to create a struct, and the purpose of this struct is going to be to store or encapsulate the supplies we have as we go through and we add different amounts of money, different amounts of lemons, and different amount of ice cubes. So we're going to go to File, New File in our Xcode project here. We can go to iOS source, and we're going to go ahead and choose a Swift file. We can choose next. And let's go ahead and call this supplies. And we can go ahead and create this. And we automatically get our foundation framework here, which is going to give us access to the Swift language. But we actually need to go through and actually create the struct ourselves. So we're going to use that struct keyword, and we're going to call this supplies, and we're going to go ahead and add some curly braces. Inside these curly braces, we can define, what properties or methods should this supplies struct know or understand or encapsulate. So we're going to start off with the properties, and we can go ahead and create a var. We're going to say this is going to be money, and we'll set its initial value equal to 0, right? We're going to have money. Our user is going to be able to have a certain amount of money that they're going to be able to save and spend on lemons and ice cubes in order to, go ahead and make some lemonade. We're also going to go ahead and create a var for our lemons, right? We need to know how many lemons we currently have. Maybe we don't use all of them in our current mixture. We can save some for later. And we're also going to go ahead and create one for ice cubes. And we're going to set this initial value equal to 0 as well. Now, the next thing we're going to do is we're actually going to use a custom initializer. And this is kind of a convenience thing. When we go ahead and we create our supplies struct, we're going to be able to instantiate it or create it with some preset values. Basically, we're going to be able to pass in some parameters and create our instance of our struct with money already set, with lemon set, and with ice cube set. And this is going to be a default case for us because when we create supplies initially for our user, we want them to have a certain amount of these items. So let's go ahead and we're going to create what's called a custom initializer. And you've practiced this before, but we're going to get a chance to see that again here. And we're going to put in a money, and we'll make this an int, and we'll say a lemons colon, and this is also going to be an int. And finally, we'll do a ice cubes, and we'll make this an int as well. And we're going to add some curly braces, and we're going to say money is equal to a money, and we can say lemons is equal to a lemons, and we could say ice cubes is equal to a ice cubes. Now, you notice that we did this a in front of this. This means that we won't have any conflict when we try to access our properties here. Remember that we can't use the self keyword because we're in a struct. Now, one of the questions you might be asking is, why did you make this a struct instead of a class? Well, we're not going to need to subclass supplies, so we don't need to create a class. So our supplies struct now has money, lemons, and ice cubes, and we're going to be able to initialize it using our custom initializer that we set up to give it an initial value of money, lemons, and ice cubes. If we use the regular initializer without using our custom initializer, all of the initial values would be set equal to 0. Now we need to create a struct in order to keep track of the prices for our different supplies, specifically our lemon and our ice cubes. So let's go ahead and create an additional struct here. And we're going to go to iOS source Swift file. We can go ahead and press next. And we can call this price. And we're going to go ahead again, use this struct keyword. And we're going to write price in. And we're going to do something a little bit different. We're actually going to use constants here for our properties. So we're going to say let lemon equal 2, and let ice cube equal 1. Now, why are we using constants here instead of using vars like we did for our supplies? Well, our prices cannot change, right? We're not going to live in the real world where, maybe there's a discount or something. Right now, we're saying for the entire life cycle of our application, the price of a lemon will always be equal to 2, and the price of an ice cube will always be equal to 1. So in this case, it makes sense to use constants here so that we can properly model what the price of our supplies will be. Now, since we now have two different models, it also makes sense to go ahead and create a new grouping. So we can go to File, New Group, and let's call this Models. And let's go ahead and drop our price in here. We can also drop our supplies in here, and we can even move our models below our storyboard here. So this isn't strictly required. It has no effect on our computer program, but it is quite nice to organize our code. So the file structure for Swift and our Xcode projects here is actually flat. These folders have no change on our computer program, but as you look through, it's really nice to organize your code. And as you get more models and more view controllers, you can have quite a few files here. So if you get in the habit of organizing things really early on, you'll get used to that. You'll also get used to how we can create groups. And you'll also start to think about price and supplies as being models, and their role is to model, right, the supplies that the user currently has or the price of our supplies. So now we're going to go back to our view controller file, and we're going to create two properties. And these properties are going to allow us to create an initial set of supplies, and it's also going to allow us to create a property for our price. So we're going to be able to access that very easily in our view controller file. Well, let's go down here. We can write var supplies is equal to supplies. And we're going to be able to use our custom initializer here. So we're going to be able to say a money. And basically what this is going to allow us to do is it's going to allow us to give some initial values for our user. So we're going to say that our user starts with $10 and they get 1 lemon and 1 ice cube, right? So they can make a little bit of lemonade off the bat. We're also going to say var price is equal to price. And this will just create an instance of our price struct, and we'll be able to access that through our class. So these properties work like any other properties we've seen before. These will be accessible in all of the functions that we have, and we see that we have quite a few functions here. But what's different about these two properties that we haven't done a ton with in the past is that they're both properties of a custom struct that we have created ourselves. And in fact, this struct has a custom initializer. And by using this custom initializer, we're able to give a default value to the supply struct, and this makes it a little bit more dynamic. We could have, instantiated or set up the value of supplies in view.did_load and said like supplies.money is equal to 10 and supplies.lemon is equal to lemons is equal to 1 and supply.icecubes is equal to 1. But that would have been 3 additional lines of code in view.did_load. By adding our custom initializer, we're able to keep our code inside of the view controller file a little bit cleaner, which is always a good thing, and we're able to abstract some of that logic into the supply struct. So as you'll see with computer programming, there's often multiple ways to accomplish a certain goal. And what we're just trying to show you right now is a different way you can think about computer programming in terms of trying to abstract information to other files and not just putting everything inside of the view controller file. However, if you use a different solution and you did it that way, that's fine. Often brute forcing your problem initially and then going back and doing some refactoring or seeing another way it could be done is really helpful when you're learning about this stuff. So right now, let's flip back to our storyboard really fast and think about some other properties that we might need in order to track some information. So right now we have two properties. We have one to track the amount of supplies we have, which is going to cover this top section here. And we also have a property for our price, which will basically figure out, okay, this is how much a lemon should cost, and this is how much an ice cube should cost. And we've kind of written these manually here, but now we're actually able to track that in code. So we have 4 more pieces of information that we're going to want to track. hopefully you can spot it. We're going to want to track the number of lemons that we have, the number of ice cubes, right, in our purchase supplies step, as well as tracking the number of lemons that we have in our mixture and the number of ice cubes we have in our mixture. So let's go back to our view controller file, and when I say track or persist this information, in the past that's meant creating a property. So let's go ahead and create a property, and our first property here is going to be lemons to purchase, and we can set its initial value to 0, and we're also going to want to track the ice cubes to purchase. We can set its initial value to 0. And let's also do lemons to mix, and we can set its initial value to 0. And finally, we're going to need to track the ice cubes to mix, and we're going to set that value to 0 as well. Now again, the order might have been a little bit different when you wrote this project out yourself, but trying to think about what information you need to store, figuring out, okay, well, I could constantly go back and maybe update on my storyboard here, update these labels, and then, ask for the information back from the label. It's a lot more efficient to just store this in a property rather than constantly converting, the string to an int, and so on and so forth. But again, if that was your solution, you were able to solve this yourself, go for it. Just go back and do a little bit of refactoring, and maybe this will be a little bit easier for you. Every time our view is loaded or a button is pressed, we're going to want to update all the labels with the new values. Instead of constantly writing those updates over and over, we're going to pack it all into a clean method. Now, we've done this before. Hopefully you can think back to the lions and tigers example, where we abstracted all of our update of our UI into a single function, then we just called update, and it was a really quick, efficient way to get the view to update with the new tiger or lion cub. So we're going to do the same thing here. We're going to go ahead and create another function. Let's do this at the bottom here. And to create a function, we'll use the func keyword. We're going to call it update main view. And this function is not going to take any parameters, so we don't need to add any in there. And let's just go ahead and add some curly braces here. So the first thing we want to do is we want to update the money supply count text. So we're going to say money supply count dot text, and we're going to set this equal to, and let's do a money sign here, and we'll do a string interpolation, and we can do supplies dot money. And we're also going to update lemon supply count, and we'll access its text property. We're going to set this equal to supplies.lemons, and we'll do lemons after. This will be a nice keyword. Instead of having the $sign, we'll be able to identify this as the number of lemons. And let's also update the ice cube supply count, and we'll set that equal to, again we'll use their string interpolation here. So we're going to say supplies dot ice cubes, and we'll do ice cubes after. So hopefully you're able to see what's going on here. We're updating our labels, and the first label, we're just accessing the text property, and we know that with text it has to be equal to a string. So we're setting this equal to the string, and we're adding a money sign here, so we have a nice identifier. And then we're saying give us the variable that we set up, or the property, supplies, and we can see that that's up here. So we're saying supplies dot money, so we're accessing the property money. So where is that coming from? Well, supplies, in our struct we created a property money here. So we're accessing a property of a property. To do so, we're using that dot notation. And we're doing the same thing here with our lemon supply count. We're doing supplies.lemons, ice cube supply count, and then we're also saying supplies.ice cubes. So you're able to see here that properties, we're able to kind of chain these things together, which is a really cool way of accessing these things really quickly. Now, one cool thing we could also be doing here is we could be using the self keyword if we wanted to. Since it's not required, I want you to get used to seeing this both ways. But we could also say self money supply count, self.supplies.money, self.supplies.ice cubes. And this makes sense, right? Because these are all properties, right? Our money supply count is an IB outlet, but it is also a property. It's a special type of property. And our supplies is definitely a property of this class. We're able to use the self keyword to access it. So I'm just going to head and undo these. Feel free to leave them in. It won't change your computer program at all. But that is absolutely valid. And again, just trying to get used to accessing that self keyword, or when you can use the self keyword, is definitely useful. So you can start thinking about it that way. We also want to update the lemon purchase count. We're going to access the text property, and we're going to say that this is equal to, we'll do our string interpolation here again, and we'll say lemons to purchase, and we're also going to update our ice cube purchase, ice cube purchase count, and we're going to set that equal to a string here. And we'll say this is going to be ice cubes to purchase. So here what we're doing is we're updating our lemon purchase count. Again, we're accessing a text property because this is a label. And in this case, we're just going to go ahead and drop in the lemons to purchase. If you want to add some sort of identifier here, you can, but I don't really think that's necessary, because we're going to be updating these numbers here, right? So they don't really need identifiers. And we're going to do the same thing with our ice cube purchase count as well. So the final thing we want to do is update our lemon mix count. So we can see in place say lemon mix count dot text is equal to a string. And we'll say lemons to mix. And let's also go ahead and update our ice cube mix count. And we're going to go ahead and drop in string interpolation, our ice cubes to mix. And in this case, we're just going to be updating the lemon mix count and the ice cube mix count. We're going to update both of the text properties here. And we're going to use, again, the properties lemons to mix and ice cubes to mix. So again, we're using a property instead of, we could go and, access this label and figure out the text, convert that over to an integer, but just easier and simpler to just keep this property and use this property to persist the information and update it from there. So the real point of all of this work is to really make it easy and efficient to update our view. We're going to be updating all of our labels. And you might say, well, wouldn't it be more efficient to just update a single label? Well, the cost to us is really, really cheap to go ahead. When we're going to refresh like one item in our view, we might as well just do all of them here. If we were going to be doing something really heavy with a bunch of images and, we had to load all of those images into memory, yeah, maybe in that case you could argue you'd only want to be updating a single thing and you'd write some logic to figure out which specific view to update. But with text, it's so quick. The UI is just so responsive. We don't have to worry about that. We can update all of our text here and not worry about any performance loss or gain. The important thing is putting all of our logic into a nice container, the update main view, rather than calling, specific updates to each label inside of all of our functions here. So we just created a helper function here named update main view. And while we're creating helper functions, before we actually start kind of getting into the guts of what this application is, let's create a helper function that will allow us to create a custom alert views with certain information, something like if the user doesn't have enough money to purchase an item or not. So let's go ahead and use the func keyword here. And we're going to call this function show alert with text. And this is going to take some parameters. So we're going to do header, and this will be a string. And we'll set up a default value here. So we're just going to set its initial value to warning. We'll talk about what this is doing in just a second. This is a little bit new. And we can also do message. And we'll say this is a string as well. And let's add some curly braces here. So the first thing we want to do is we want to create our alert here. So we're going to do var alert. And we actually want this to be a UI alert controller. So we're going to say UI alert controller. And this is the class UI alert controller. And this takes some parameters. And we see that if we scroll down here, we actually get some autocomplete, which is awesome. Xcode's providing this. And the title, let's just use our parameter. We're going to use the header, right? We get that from up here. And our message will be our message parameter. And our preferred style, we'll just use the default. So we're going to say UI alert controller style dot alert. And then what we need to do is we're going to say alert dot add action, and we're going to say UI alert action, and we're going to say title, and we'll use the string OK, and the style is going to be UI alert action style, and we'll use default here, and the handler will be nil. And then finally, we're going to present this alert. So we're going to say self.present view controller. And we're going to do our alert here. And we'll say that we do want it to be animated. And the completion will be nil. Now, let's go over this bit of code we wrote. There's a couple cool things going on here that I wanted to show you. And the first thing is in our function header here. So our function name, show alert with text, this is pretty normal. We have some parentheses here. And the first thing we're doing is we're using a parameter, and the parameter's name is header. And we're saying it's a string, but we're giving it what's called a default value. So if we don't pass anything in here, it will automatically default to warning. And by adding this default, when we call the function show alert with text, all we are required to do is pass in a parameter for message. The header is optional because we've set up this default value. And we can also now update the header if we chose, so we could overwrite this warning by in fact passing in this parameter. So we'll see how that works when we actually call this function show alert with text. Now the next thing we're doing is we're creating a variable, and we're saying that this variable's name is alert. And we're saying that it's going to be an instance of UI alert controller. And this allows us to present an alert view on our screen with a given header. And in this function, we're going to be passing that in ourselves, as well as a message. And again, we're going to be passing this in as a parameter. For our header, it's optional. For a message, it's required. And then we're just going to use the default style here, preferred style. So we just use UI alert controller style dot alert. And if you're curious again as to what any of this stuff does exactly, you want to take a look at the documentation, you can just hold down the Alt key and press on things here in order to see, what Apple's has written about this. UI alert controller, we can take a look at what this does exactly according to Apple. You can also hold down the command key and press on UI alert controller, and this will take you to the file where the UI alert controller specifically the class is defined. So we see that UI alert controller is here. It's a subclass of UI view controller, so it adds some additional functionality on top of it. And these are the functions and variables available inside of the UI alert controller class. So we can just press this back button up here to go back. The next thing we're doing here is we're doing what's called adding an action. And basically, it's important for us to add an action here so that the user can exit the UI alert view. So we're going to just add the default title OK, right? They're going to agree to what we're telling them. And we're just going to set the UI alert action style to be default. These will be pretty consistent when you're using UI alert controllers. You just kind of have to do a little bit of research online, or in this case, you're watching the video, so you'll know that for preferred style, you can use this default. And for the style here, when we're adding the action for the OK button, we can use UI alert action style default. Now, both of these are enumerated types. We'll talk about what these mean in the future. For now, we just need to use these defaults.
And for the last option here, we have nil. And nil basically means we don't need a handler. We might get to one of these in the future, but for now, we can just set this parameter equal to nil and it'll work fine. We're going to see nil used in just a second down here in our last bit of code here, which says self present view controller. And this takes a UI view controller instance as one of its parameters, so we're able to pass an alert. We saw that UI alert controller is a subclass of UI view controller. So as a result, we're able to pass alert in here. It's a type of UI view controller. So we're going to be able to present that on the screen, which means show this instance of the UI view controller on the screen. And when we show it, we do want to in fact animate it. So we'll get like a nice pop-up, and we'll set that equal to true. And a completion here would allow us to do a bit of code, when this action had finished occurring, specifically when the presentation of the new view controller was done. But we don't need to do anything like that. We don't need, so an additional bit of code here. So we can just set this parameter equal to nil. And that's our new function, show alert with text. Again, we're going to be calling alerts in so many different spots. There's the potential for any number of these buttons to cause a fail in terms of, you don't have enough money to complete this action, that it made sense to modularize the show alert with text rather than creating these alert controllers in each function where we need to show an alert view. Let's check out the current status of our application. The first thing we're going to do is we're going to call the update main view function inside of viewDidLoad. And the reason we're going to do this is so that we can initially set up what our view should look like in terms of the supplies or the default supplies we're going to set up for our user. So in order to do that, we're going to simply type in update main view. And let's go ahead and run our application here. Now I'm going to switch this over to the iPhone 5S. You can feel free to use, the 5 or, the 4. If you set up the storyboard with a different iPhone in mind, feel free to use those size constraints. Again, we're not really focusing on, really getting all these different auto layout and different views set up. We just want one consistent view so we can focus on the code for now. So now we see that our view has launched here, but we have one little issue here. We need to expand our labels, so we'll do that in just a second. We also see that we're starting with $10 and we get 1 lemon and 1 ice cube, so our labels are in fact updating properly. And we currently have 0 supplies purchased, and we also have 0 lemons and ice cubes in our mix. So let's go ahead and just expand our labels here. And if you've already done this, you're good to go. But we want to just make these a little bit bigger, just so we can be sure that there's enough space for these things. And let's go ahead and rerun our application here and confirm that, in fact, our labels are large enough to hold the proper information here. So now we see that our labels are, in fact, updating properly. So this means our update main view function is working, and we're able to see our information in our simulator. Now we're going to work on the start day button, specifically what happens when we want to start our game. So we're going to go down to the start day button pressed function, and I'm going to go ahead and add a little bit of space here for us to work in. And the first thing we're going to do is we're going to simulate creating X potential customers. So a customer prefers either more ice or more lemons, and we're going to be able to set those preferences in just a minute. Also, if your brew fits the specified preferences of the customer, you're going to get $1 for the sale. If they don't like what you have, you get nothing. So there's a little bit of risk here. So in order to generate our customers here, we're going to create a constant. We're going to say let customers equal, and we're going to make this an int, right? We can't have half a customer, so we don't need to make this a double. And then we'll do arc for random underscore uniform. And this is going to take an unsigned integer 32. And we're going to do, need a parenthesis at the end here. And into this we'll pass in our numbers. So we're going to generate 10 potential customers. So we're going to push in 11 here. Why? Because, well, it's going to be n minus 1 since the first random integer could be 0. Right? So this is going to randomize it. So we want 10 potential customers, and we need one more parenthesis on the end there. So this is going to generate, a number between 0 and 10. And we're going to just print this out.
just so we can, take a look at how many customers are being generated to make it easy to check our math later on. So let's give this an identifier. We can call this customers, and let's pass in our parameter here, and we'll pass in customers. Oh, I should add an S. Let's pluralize this because, this could represent more than one customer. Now, this is actually a really good time to point out, right? Customer would have worked here. That would have been completely valid. But as you're writing your code, you want to be as explicit as you can about your variable names here. Specifically, it makes so much more sense to call this constant customers because there could be more than one. So if someone is going through reading your code becomes much more readable and understandable. So the next thing we're going to do is we're going to iterate through our customers. So what do we need? Well, we can use a for loop here. So where you can simply say for x in 0, and we'll use 3 dots here, and we can say customers, and we'll add some parentheses here. This is just our for in loop. And actually I need to remove the space here, the 0 ... customers needs to be connected here. And this is a little bit different than iOS and Objective-C, where it was very white space blank. There are a lot of instances where you have to make sure that you have these things properly spaced. Otherwise, you'll get a compiler error. So what's going on here? This for loop looks slightly different than what we've done in the past, although we have used for in loops before. In the past, we've always done for x in some sort of array, and then x would be the values in the array, right? We'd start at the first value and move on through the array, and we'd be able to access those values by using the variable x. Well, in this case, we're simply saying go from 0 to the number of customers, or through the number of customers here. So we're going to do from 0 up to whatever random numbers generated here. And in each case, x will iterate starting at 0 and move to 1, 2, 3, up to the number of customers. So if, for example, the number of customers returned is 7, x will print out 0 through 7. Before we get a chance to loop through each customer and randomly generate their taste, we want to first create the lemon to ice cube ratio. We're going to make this a constant. So let's do this right below the customers here. And we can say let lemonade ratio equal, and we'll say it's going to be a float. You could also use a double here. Either one would work. And we'll say lemons to mix. And we'll divide this by another float, and we can say ice cubes to mix. And what this is going to do is it's going to give us the ratio of the lemons that we've selected that we want to mix to the ratio of ice cubes we want to mix. And this way we'll be able to determine if the preference of the customer is for more lemons, more ice cubes, or the same amount of lemons and ice cubes. Before we do that, let's go ahead and just print out our lemonade ratio, just so we can have easy access again to the information in our start date button pressed function. Later on, if we don't want to see this information, we can quickly comment out these two print statements. But for now, it would be nice to see what's actually being inputted and being randomized here to make sure that our randomizer is in fact working. So we can say lemonade ratio, and we'll say that we're going to enter our lemonade ratio here. And this will just print it out for us so we can quickly identify what the lemonade ratio is to make sure that this for loop is going to work properly. So the first thing we want to do here is we want to figure out what the preference is. And we'll just randomly generate this. We're going to make this a constant. And we're going to say let preference, it's going to be a constant, and we're going to say double. And we're going to do arc for rand uniform, and we'll do uint 32. It's not inputting correctly. There we go. And let's go ahead and add another set of parentheses here. This autocomplete is a little frustrating sometimes. And let's enter in 100 here and make sure we have the right number of parentheses. And then we'll divide this value by 100. So what we're going to do is we're going to need a double back. It'll be 0 through 100.0 because it's a double, right? So we're not going to get an integer back here. And then we can divide that by 100, and that'll give us a preference that will be a double. All right, so this will be in decimal form, right? So if we did this with just an int, we wouldn't be able to get the decimals back. And the decimals are going to be important because we're going to write down here if preference is less than 0.4, and we're going to do the double and operator. I'm going to say lemonade ratio is greater than 1. We're going to say supplies dot money, and we'll do plus equals 1, and then we can do a print line statement here, and we can say paid. And if you want to, you could do something like paid from if statement, or paid because preference was less than 0.4. There's a few things you could do to identify. I think paid is enough here. So let's take a look at what we're doing inside of this if statement. We're first going to test to see if our preference is less than 0.4. And then we're going to use our double ampersand here, which is going to say also, right, both of these statements have to be true for this if statement to evaluate. The lemonade ratio must be greater than 1, which means that there's more lemons than ice cubes inside of the current mixture. And if that's the case, then we're going to update our supplies property, and we could also use the self keyword here. We could say self.supplies.money plus equals 1. All right, I'm going to remove the self. But again, this is a place you could put the self. And then remember that plus equals 1 is the same thing as writing supplies.money is equal to supplies.money plus 1. Sorry, it's just a shorthand. So we're going to be doing the same thing for our second preference here, which is going to be else if preference is greater than 0.6 and lemonade ratio is less than 1. And we'll say that supplies dot money plus equals 1, and again we'll do another print line statement here to let ourselves know that the customer got paid. So what's going on here? Well, we're saying that if the preference is greater than 0.6, and again we're doing the double ampersand, and we're saying the lemonade ratio is less than 1, which in this case means that there's more ice cubes than lemons in this current mixture, then we're going to go ahead and update our supplies.money, and we're going to be adding 1 to it, right? So remember, supplies is a property. Supplies also has a property money, and we're able to update its value with a number. Let's also write an else if we're in between 0.6 and 0.4. So we're going to go ahead and write else if. We're going to write preference is less than or equal to 0.6. Important that we add the equal sign. We'll do our double ampersand here. And we'll say preference is greater than or equal to 0.4 and lemonade ratio equals 1. And we'll do supplies.money plus equals 1. And we'll do another print line statement, and we'll say paid. And we can add an else statement at the bottom here. And we'll go over what's going on in the last one in just a second, but let's just add this little bit of code here. We'll do print line, and we'll say no match, no revenue. So in this else if statement, we actually have 3 different tests we're doing here. The first one we're going to be doing is we're going to be testing to see if the preference is less than or equal to 0.6. So notice that we use the equal sign because above we're only testing if it's greater than 0.6. And for our preference as to whether or not it's greater than or equal to 0.4, notice above we're only testing if it's less than 0.4. So we're doing the equal sign to make sure that we're accounting for all of the different percentages we could be getting back from our preference constant. Finally, we're going to say, is the number of lemons equal to the number of ice cubes? So finally, we're going to add an else statement at the bottom here. And this is basically, if none of these evaluate to true, we're going to go ahead and say that there's no match, no revenue. We're just going to add a print statement, but basically the user will get no money. Right now, there are 8 buttons that the user can press. These buttons include the ability to add, remove supplies, such as buying lemons and ice cubes, and adding and removing supplies to mix. For each button press, a few small updates need to occur to our instance variables and our properties so that our supplies and the amount of inventory that we have is properly updated. Let's go through each function together, and we're going to make sure that we remember to update the view after we press each button. So I think what you'll really see as we go through these functions, all of this work we've done in terms of creating these modular update main view functions and show alert with text functions will really come in handy, because we're going to be able to create these updates very fast as opposed to having to write all this code over and over again. Let's get right into the purchase lemon button pressed function. And in this function, we want to update the number of lemons to purchase. We're also going to want to reduce the amount of money, and we're also going to want to increase the number of supplies that we have. So we also want to account for situations where we don't have enough money, and in this case, we're going to show an alert view. So hopefully you can think about an if or an else statement occurring here, because there's two different circumstances that can occur. Let's see how that's done. Let's go ahead into our function here. We're going to write if supplies.money is greater than or equal to price.lemon, and we'll add some curly braces here. And basically what we're saying, if the current amount of money that we have is greater than or equal to the price of a lemon, we can in fact purchase a lemon. We have enough money to go ahead and buy a lemon. So we're going to say lemons to purchase plus equals 1. Basically we're going to increase the number of lemons to purchase. And we could also say supplies.money minus equals price.lemon. And finally, we're going to want to update our supplies. So we're going to say supplies.lemons plus equals 1. So what's going on here? The first thing we're going to do is update lemons to purchase, which we remember is the instance variable or property that we created, so that we would be able to update our labels text property with the number of lemons to purchase. We also can use the self keyword here because this is a property, so it would be perfectly legal to say self.lemons to purchase, but we don't need to do that because we don't have any conflicting, local variables or anything like that. So we can simply do lemons to purchase. That's fine as well. And the next thing we're going to do is update our supplies. So we're going to update, the current amount of money that we have. We're going to reduce or subtract the price of our lemon. So we say price.lemon. And then finally, we're going to update our supplies to add an additional lemon to it. So we're going to say supplies.lemons plus equals 1. We also want to add an else statement below this. And you can do this on a single line. You could also drop this down if you wanted to. That would be completely fine as well. And inside the else statement, we're going to say show alert with text. And hopefully you remember that this is the function that we created. And what this basically does is it shows an error message on the screen if we don't have enough money to purchase a lemon. So what is the message we want to send here? Well, we actually don't need to use a header here. We can simply remove the header since we have a default. And we can put in you don't have enough money. Now, why is this okay to do it this way? Why don't we need that header even though it defaulted that way with the autocomplete? Well, if we scroll down, we remember that our show alert with text header had a default value for its string, which was warning. So in this case, it's optional to pass the header, but we absolutely have to pass it a message. So you don't have enough money. We're also going to go ahead and update the purchase ice cube button pressed function. And this is going to be very similar to the lemon, except we're going to be using the ice cube properties instead of the lemon properties. So hopefully you can guess, we're going to say if supplies.money is greater than or equal to price.icecube, and we'll say ice cubes to purchase, and we're going to say plus equals 1, and then we're going to say supplies.money minus equals price.icecube. And finally, we're going to say supplies.icecubes plus equals 1. And this is, again, the same thing we did up here. I'll go through it one more time. We're going to basically go ahead and run an if statement here. And this if statement is going to check to make sure that we have enough money to purchase an ice cube. Remember that the price of our ice cubes and the price of our lemons are different. Then we're going to update the ice cubes to purchase property. And again, we could use the self keyword to access these properties, but we don't need to. And we're going to say plus equals 1. And this is going to go ahead and add 1 to the ice cubes to purchase so we can update our label properly. And then we're also going to update our supplies money by removing or subtracting the price of the ice cube. And we're also going to update our supplies.icecubes by adding an additional ice cube to it. We're also going to write an else statement like we did above. And we can say else. And let's do another show alert view with text. And this time, let's go ahead and override the header. So we can say error. And we're going to say you don't have enough money. So this is just a little bit different. We don't have to do this if we wanted the header to be warning. But in this case, let's have a different header. So we can add error here, and if we try to purchase an ice cube and we don't have enough money, instead of saying warning at the top, it'll say error at the top. Now there's one additional step we need to do in both of these functions, and hopefully you can guess it's going to be to call the function update main view. Right after we do this sort of logic here, the view doesn't know to update until we call update main view ourselves, right? And this is going to go ahead and update. If we take a look here to update main view function, it's going to update all of the labels with the current amount of supplies and the current lemons to purchase and ice cubes to purchase, as well as our mix. So to call that, we're just going to say update main view, and we can also do this here. Now, if you have an idea how to go ahead and move forward through these next 6 functions here, feel free to jump ahead. I'm going to go through all of these again just in case you're not sure how to do it yourself. But hopefully you can see that this is going to be fairly repetitive in terms of how we're going to go ahead and fill out the functionality for these functions. So now we want to figure out how to do our mix lemon button pressed and mix ice cube button pressed functions. So let's go ahead and add a bit of space to write this code. And the first one we want to do is mix lemon button press. So we first need to determine if we have enough lemons to mix. How can we do that? Well, let's write an if statement here, and we're going to say if supplies dot lemons is greater than 0. And what is this testing here? Well, we're testing to make sure that we actually have some lemons in our supply. And if that number is greater than 0, we can go ahead and remove one of these lemons from our supply. So we're going to say supplies.lemons minus equals 1. And then we're going to say lemons to mix, and we're going to add 1. And then we need an else statement below this, right? If in fact we don't have any supplies, lemon supplies, we're going to need to show an alert. And let's go ahead and just use a message here. And we're going to say you don't have enough inventory. And then we need to update our main view. Well, what are we doing here? The first thing we're doing is we're writing a test here to make sure that we have some lemon supplies. And if in fact we do, we're going to go ahead and remove one of our lemons from our lemon supply. And then we're going to add 1 to our lemon mix. We also have an else statement, which is an alert, and we're basically saying that, okay, if this bit of code runs here, that we don't have enough lemons in our lemon supply, and maybe you could add a little bit of additional information here, suggest that they go purchase a little bit of lemons if they have enough money. And then finally, we're going to update our main view so that we'll be able to reflect the changes to our mixture in our label. We also want to update our mix ice cube button pressed, and again this is going to be very similar to our mix lemon button pressed function. So we're going to simply test if supplies dot ice cubes is greater than 0, and then we're going to say supplies dot ice cubes minus equals 1, ice cubes to mix plus equals 1, and then we'll add an else statement below this, and we'll say show alert with text. We'll go ahead and remove our header here, and our message will be you don't have enough inventory. Let's also go ahead and do the unmix lemon button pressed and unmix ice cube button pressed functions, because by this point, hopefully you have a pretty clear idea about what you're going to need to do. We're just going to be doing the opposite of the mix lemon button pressed and the opposite of the mix ice cube button pressed functions. So let's go ahead and unmix this. We're going to say if lemons to mix is greater than 0, we're going to say lemons to mix minus equals 1. We're going to remove one of the lemons from our lemons to mix. We're going to say supplies dot lemons plus equals 1, and we'll add an else statement below this, and we're going to say show alert with text, and let's go ahead and add a message here. We're going to say you have nothing to unmix. Right, the user doesn't have any lemons to mix. And oh, looks like we forgot to do the update main view. Specifically, I forgot to do the update main view in the previous function, and we need to do it here as well. Right, we need to update our labels. And then let's do the unmix ice cube button pressed function. So we're going to say if ice cubes to mix is greater than 0, we'll say ice cubes to mix minus equals 1, supplies dot ice cubes plus equals 1, and we'll add an else statement below it, and we'll say show alert with text. Again, let's not have a header here. We only did a custom header once, and we'll say you have nothing to unmix. And then finally, we're going to update our main view. So let's go ahead and test to make sure that this works. We can go ahead and run our application. I'm doing this on the iPhone 5S right now. And we should be able to update or change the values in our mixtures, as well as purchasing of supplies. So let's first try purchasing a supply. We should see 8 appear in the amount of money that we have, and we should see 2 for the lemons, and we see that this is updating properly. We could also update ice cubes here. We still have a little bit of money. Let's try doing this too many times. Now we have $0 to try to purchase this, and we get this warning. Notice that this is our custom header here. You don't have enough money. So if we try this with the ice cubes, we get error. Notice the difference there in our headers. Now we can go ahead and remove this, and we see we're getting our money back. And it says we don't have anything to return, and we can also return this as well. So we're back to where we started. Now let's try updating our mixture. Warning, we don't have enough inventory, so we can go ahead and put that back. And let's try this, and we see that this is also working. So we've been able to update both our mixture and our purchasing of supplies. Now let's go ahead and actually play the game and see how that works. We're going to go ahead and purchase a lemon, purchase an ice cube. And let's add one of each one of these to our mix, and let's go ahead and start our day. So right now we see we got paid once, and we had 2 where we had no matches and we got no revenue. So right now we're able to get paid, and we're able to, sometimes the ratio doesn't work. It's not working properly, so the customers are working. But we have an issue here where it's not clearing our mixture, and it's also not clearing our purchase supplies. And so this is not updating properly. So in our next video, we're going to have to figure out how to clear our purchases